So hi guys, these are the 50 most important questions for NEST 2025 for maths, okay? So hopefully once you go through all these solutions, every topic that you've studied so far, you'll get a little bit more clarity about all those topics and you'll understand what kind of questions are actually asked in NEST, okay? Because you've already revised all the topics, you know the theory, you know the formulas and so on and so forth. Now the question is what kind of questions are asked in the exam. So this video is going to help there. But if you feel like there's a particular topic where you're slightly lagging or if there are some concepts that you feel like you need to revise again, make sure you go back and revise those topics, okay? So with that, let's start. So the first question is find the difference of the two sets. The first one is nothing but the interval, open 0, 1. And the second set is all those numbers x such that 1 by x is an integer, right? So what is our set B? Our set B is nothing but 1, half, 1 by 3, so on and so forth, right? So when you take the set difference of this, you want all numbers in 0, 1 except the points which are reciprocal of integers, right? Okay. So now let's look at the option. First of all, observe that in option D, when you take the union of these sets, 0 is a constant for all the sets, right? So in the overall union, 0 is going to be there, which is not allowed, right? Because in our interval, we don't have 0. So D is clearly incorrect. Now similarly, if you look at option B, this interval itself doesn't really make sense, right? 1 by n, if you observe, 1 by n is always going to be greater than 1 by n plus 1, right? Okay, so this interval doesn't really make sense. So B is also incorrect. Now we only have to work with option A and C. So if you observe option A, what is given to us? Say 0 is here, 1 is over here. So half is going to lie somewhere around here, okay? So n equal to 1 gives you half all the way till 1, both open, right? So you get half till 1. Second one, when you put n equal to 2, you'll get 1 by 3 till half, right? So somewhere around here till half, right? Third one, you'll get 1 by 4 till 1 by 3, then 1 by 5 till 1 by 3, and so on and so forth, right? So once you take the union of all these, you can see that every number gets covered except these endpoints. And these are precisely the points that we want to avoid in our overall union, right? So this set works, okay? The union of all these intervals is actually going to work for us, right? But when you take the intersection, if you take the intersection of the same sets, right? See, option A and C, they have the same intervals that you're working with, right? When you take the intersection, observe that the intersection of the first two sets itself is empty, right? So if you take the overall intersection, this is overall thing is going to become empty, which is not allowed, right? So C is also going to be incorrect. So the right answer is option A for us, right? Okay. Go to question 2. Let A1, A2, A3, so on and so forth be subsets of a set X such that AJ plus 1 is a subset of AJ, right? So these are nested subsets, okay? If capital A is defined to be the intersection of all these sets, then which of the following options is correct? So for this, the first one, of all AJs are non-empty, then A is non-empty. Just observe, if I take my AJ to be, if I take a counter example inspired by the previous problem, if I go with say 0, 1 by n, or 0, 1 by j, right, for every AJ. Then if you look at the intersection of all these, it's going to be empty, right? The intersection of all these sets is going to be empty, right? Just like the previous case, right? Except these were shifting. If I just look at this, so it's going to be 0 till 1, then 0 till half, then till 0 till 1 by 3, and so on and so forth, right? So when you take n going to infinity, this is supposed to converge to the left end point, right? But the left end point is not included for us, right? So this overall intersection is going to be empty for us. So even if all the AJs are non-empty, A doesn't have to be non-empty for us, right? So A is incorrect. If all the AJs are infinite, then A is infinite. For this, let's just slightly modify this. So for option B, let's just go with 0, 1 by j, open. So when I take the intersection of all these sets, what am I going to get? Now capital A is going to look like just a singleton 0, right? So here the intersection of AJ is going to be the singleton 0, right? So even if all, so observe, obviously these sets are all infinite, right? Between any two real numbers, we know there are infinitely many real numbers, right? So A is not infinite even though all the AJs are infinite, right? So option B is incorrect again, okay? Come to option C. There exists a J naught such that AJ is non-empty. AJs are non-empty finite sets for all j greater than or equal to J naught, then A is non-empty. Yes, why? Because after a certain point, for any A, let's say A J naught, okay? It's a finite set, right? It only has a finitely many elements. So after this, at some point, either you keep the number of elements constant and you keep the same elements, right? Because these are all subsets. Or you decrease the number of elements, right? You decrease the cardinality. No wonder, no matter how you reduce it, right? After a certain point, the worst you can do is work with a single element, right? At some point, you'll have to work with a single element, right? You can't go any lower than this, right? Because these are all non-empty finite subsets, right? So which means when you take the overall union, if you take the overall intersection, sorry, This element is always going to be there, right? So A is going to be non-empty for us. So C is correct, right? D, if all the edges are infinite, A is non-empty, then A is infinite. Not true. This same example works for D as well. Edges are all infinite. The intersection is non-empty, but it's not infinite, right? So D is also incorrect. Okay. So that's question 2 for us. Come to question 3. For any real number, define box x. Now you're defining bracket of x as the fractional part of x, right? Then which of the following options are correct? So if we go with the first one, observe that this quantity, box of x plus y, is nothing but an integer. So I can send it inside, right? I know that box of x plus n is equal to box x plus n whenever n lies in the set of integers, right? So this first right hand side is going to look like box x plus y plus z plus fractional part of x plus y. Now if I combine this and this together, what will I get? Box of x plus y plus fractional part of x plus y is nothing but x plus y. So this will turn into x plus y plus z, which is precisely my left hand side. So option A is correct for us. Similarly, coming to option B will just use the idea that fractional part is going to be x minus box x, right? So if I look at the right hand side of this, I'll get what? Fractional part of this is the number itself minus box of it, right? So box of fractional part of x plus y plus z. Now again, this box of x plus y, sorry, this fractional part of x plus y can be written as what? X plus y. Keep the z here. I'll have to subtract the fractional part of it, right? Sorry, the box of it. So I'll subtract box of x plus y. And you already have this quantity, right? Again, if I take this minus sign common, I'll get a plus here. Send this inside. X plus y plus fractional part of x plus y is giving you x plus y, right? This will turn into x plus y plus z minus box of x plus y plus z. Think of this as a number, so the number minus box of it is going to be the fractional part of it, which is precisely my left hand side. So B is also correct for us, right? Coming to option C, box of xyz is equal to box of xy times z times fractional part of y, right? So this clearly looks like it's supposed to be incorrect, right? And we can take a very simple counterexample. Take x equal to half, y equal to 1 by 4, and say we take z equal to 8, right? Then xyz is going to be 1, right? So the box of xyz is going to be 1. So left hand side is equal to 1. Now if I look at the right hand side, fractional part of, so what is xy? Xy is 1 by 8, right? So the the box of xy is going to be 0. So this quantity turns to be 0, right? So this is incorrect for us. Coming to option D, if z lies in between 0 and 1, then fractional part of xyz is less than fractional part of xy. Incorrect. Why? See, if z lies in between 0 and 1, I can say one thing, which is that xyz is less than xy. This is true, okay? This is definitely true. Now observe that just because a number is smaller than the other number doesn't mean the fractional part is going to be smaller. Simple example for that is just take minus 2 by 3. Sorry, take minus 1 by 3 and take 1 by 3, okay? Right? Take minus 1 by 3 and take 1 by 3, okay? So in this case, you can see that clearly fractional part of minus 1 by 3 is going to be 2 by 3. Fractional part of this is going to be 1 by 3, right? So just because a number is smaller than the other number doesn't mean that its fractional part is also going to be smaller, okay? So D is going to be incorrect, right? Okay. Clear. Fine, let's go to the next question. For 3 arbitrary real numbers, RST, which of the following is true? First one, observe that what do we know? We know that fx equal to x cube is a strictly increasing function, right? Which means whatever the minimum of it is, right? Okay, whatever the minimum of RST is going to be, once you cube it, the minimum of r cube, s cube and t cube is also going to be the same, right? If r is smaller than s, then r cube is going to be smaller than s, right? Strictly smaller because it's an increasing function. So this left hand side and right hand side are going to be same, so A is clearly correct. Option B, it's not going to be. Why? Because now you're squaring it, right? When you take an even part, you have that entire concept of the negative sign turning into the positive sign, right? So for example, if I take, say, minus half, say I take 0 and I take 1, okay? Something like this. Or let's take minus 1 by half, minus 1 by, let's go with minus 1 and 0, okay? Let's take these 3 values. So minimum of RST is going to be minus 1 here. So the left hand side is going to be minus 1 squared, which is plus 1. But the right hand side is going to be the minimum of the squares of this, right? Squares of this is going to be what? 0, 1 by 4 and 1. Minimum of this is going to be 0. So clearly they are unequal, right? The left hand side and the right hand side. So B is incorrect. Same goes for modulus as well, right? Again, if I work with the same example, minimum of RST is going to be minus 1. So mod of that is 1, right? So LHS is going to be 1 for us. Right hand side, minimum of mod r, mod s and mod t, which is going to be 0. So again, these two are unequal. Option D, sign of the minimum. This is also going to be incorrect. Why? Because sign is increasing only till a certain point, right? It's increasing in a certain interval. It could be 0 to pi by 2 or whatever. But overall sign is not a increasing function, right? So if I simply consider the points, say I take the points, you take any points, I'll go with pi by 4, pi by 2 and pi, okay? So what is the minimum of these three? Minimum of RST is going to be pi by 4. So sign of that is going to give you 1 by root 2. This becomes 1 by root 2. But the minimum of the sign of these three values, 1 by root 2, 1 and 0, the right hand side is going to be 0 again. So again, they are not going to be equal. So D is also incorrect, right? So the only correct option is option A. The entire idea was finding a function that is going to be strictly increasing, okay? That's the idea. Cool. Alright, so let's look at the next question. For a positive number, define sigma to be the sum of the divisors, yeah, and phi of m to be the number of elements of the set. So phi m basically counts the number of integers less than equal to m that are co-prime to that number, okay? So one thing you need to know for this question is what are the closed forms for this, okay? So sigma of n, so if I have the prime factorization of any number, right? Say p1 power alpha 1, p2 power alpha 2, all the way till some pk power alpha k, right? If this is the prime factorization of a number, then these two functions have their closed forms respectively as product of pi to the power alpha plus 1 minus 1 divided by pi minus 1 and the product of this, okay? Similarly, phi of n is nothing but p1, 1 minus 1 by p2, 1 minus 1 by pk, okay? For a general number, this is what happens, okay? In this case, your numbers are comparatively simpler, right? They're just powers of primes. So it makes this entire calculation a lot easier. But in general, remember these formulas, okay? So now let's look at the option. So Fm is sigma by phi, okay? So Fp, if I take a prime, if I consider a single prime, f of p is going to be what? Sigma p. For a prime, what are the only divisors of that number? 1 and the prime itself, right? So sigma of p is going to be 1 plus p divided by what is going to be phi of p? Phi is all those numbers that are co-prime to p and less than p, right? So every number less than p is going to be co-prime to it, right? Because the prime only is divisible by two numbers, 1 and itself. So phi of p is going to be p minus 1, right? So this can be written as p minus 1 plus 2 divided by p minus 1, which gives you 1 plus 2 by p minus 1, right? This is what phi of p is going to be for any prime. So if I check the first option, right? Phi of p is less than equal to, f of p is less than equal to f of q, right? Which means 1 plus 2 by p minus 1 is less than equal to 1 plus 2 by q minus 1. This just cancels out, 2 and 2 will cancel out. You want q minus 1 to be less than equal to p minus 1, which implies you want p to be greater than equal to q, right? And here you have the exact opposite thing, right? So fp is going to be less than equal to fq if and only if p is greater than equal to q. In this case, you have the opposite. So A is incorrect for us, right? Option B, let's go with option C first because this also works with a single prime. Fp is equal to Fq. So clearly now if I work with this equality case, you want 1 plus 2 by p minus 1 to be equal to 1 plus 2 by q minus 1. Cancel this out, you'll get p minus 1 equal to q minus 1, which means you want p equal to q, okay? So there are primes p not equal to q such that these are equal. That's incorrect, right? For these two functional values to be equal, you want p equal to q, right? So C is also incorrect for us. Now let's look at option B and D, right? So if I work with a power of a prime, what happens? Let's see that, okay? So if I work with f of some prime to the power something, okay, let's go with p power s. This is going to be sigma of p power s. Now what are the divisors of p to the power s? 1 plus p square all the way till p to the power n minus 1. Again, if you plug this in the formula, you'll get the same thing, right? So that turns out to be, all the way till p to the power s, okay? This turns out to be p power s plus 1 minus 1 divided by p minus 1. This quantity is sigma of p power s, right? And if I work with phi of p power s, what will I get? That is going to be p power s times 1 minus 1 by p. So that is p power s minus 1 times p minus 1, right? So this quantity f of p power s will be nothing but p power s plus 1 minus 1 divided by p to the power s minus 1 times p minus 1 whole squared. Okay, this is the value of f of p to the power s. Now what are the options you have to compare? First one is you have to look at p to the power r less than sorry, f of p to the power r less than f of p to the power s, right? So if this thing is true, then you'll get that you want p to the power r, f of p to the power r, which is going to be r plus 1 minus 1. Okay, you have to check if this is true when you're saying that r is less than s, right? So if r is less than s, first of all, this quantity cancels out, right? R less than s means you can take this to the other side. What will you get? You'll get p to the power r plus 1. Or forget about it, just cross multiply actually. That's way easier. So if I cross multiply, what will I get? These two multiply together to give you p to the power r plus s minus p to the power s minus 1. That should be less than, again, if you multiply these two, you'll get p to the power r plus s minus p to the power r minus 1. Cancels out, you want p power r minus 1 less than p to the power s minus 1, which is true if and only if r is less than, r minus 1 is less than s minus 1, which gives you r less than s, right? So if r is less than s, this is indeed true, right? So option B is correct for us. And again, if you look at option D, if you multiply this using this formula and this formula, you'll see that it's going to be precisely the product of this and this, right? Okay, so option D is also going to be correct for us. And this property is known as multiplicative function, okay? Okay, so because phi and sigma are both multiplicative function, this option holds directly, okay? Or otherwise, you can just use this formula and check that it's true, right? So that's question 5 for us. Coming to the next one, question 6. For any real number t belonging to the open interval 0, half, consider the quadratic blah blah blah. If alpha t and beta t are the roots of pt of x, then which of the following is false? First one is talking about whether the roots are real or imaginary, right? So what do you need to do? Check the discriminant of this. So for any quadratic, delta t is going to be b square. So that's 1 minus t whole squared minus 1 by t whole square minus 4 t minus t square into t square. So this quantity can be written as, if I take 1 minus t common, I'll be left with 1 minus t minus 4 t square into t, right? So 4t cube. Okay, right? This is what I'll get. Cool. Now from here, what else can I do? This can be rewritten as 1 minus t. If I factorize the second quantity, it will turn into 1 minus 2t into, you get what? T square, 2t square ये बीच वाला पॉज काट देना इस क्वेश्चन में, ठीक है? ये बीच वाला पॉज काट देना. Times 2t square plus t plus 1, okay? Now see, this quantity is clearly positive because the discriminant is less than 0, leading coefficient is greater than 1, right? So this quantity is going to be positive. This determines the sign of this, right? So if I use wavy curve, what will I get? You have half over here. You have 1 over here, right? This is what it's going to look like. So if you observe less than half, for any value less than half, this function is going to be positive, right? So delta t is positive, hence for t in this interval, you can say that alpha, beta are not going to be imaginary, right? They're going to be real. So option A is actually incorrect. And the question is, which of the following is false? So option A is going to be correct for us. Option B, if I find infinitely many values of t, the corresponding roots are irrational, and for infinitely many values, they are irrational. Again, that's true, right? I can choose any value. Whether you make it rational, irrational, real, complex, it's up to you, depending on the value of delta t that you take, right? You can take it to be a perfect square. If you take it to be a perfect square, you'll get what? You'll get rational roots. If you take it to be rational, you'll get irrational roots, right? So option B is going to be clearly correct for us, right? So the option 2 is, statement true is true, which means option B is incorrect for us, right? We can't choose it. Option C, if alpha and beta are real and positive, then one of alpha t beta t is greater than 1 and the other one is less than 1. So for this, observe that if I call this pt of x, pt of 0 is going to be what? T square, which is positive, right? So at 0, it's going to be positive, right? And at 1, if I put x equal to 1, what will I get? So pt of 1 turns out to be t minus t square minus 1 plus t plus t square, right? So this and this will cancel out. You'll be left with 1 minus 2t. Now see, t lies in between 0 and 1. Sorry, 2t minus 1. So 2t, if t lies in between 0 and half, 2t lies in between 0 and 1. So 2t minus 1 lies in between minus 1 and 0. So it's clearly negative, right? 2t minus 1 is going to be negative. So pt of 1 is going to be negative. right? Yep. So if it's positive here, it's negative here. Clearly, it needs to cut the x-axis somewhere in between these 2 points, right? Yep. This is what you'll get. And again, as x goes to infinity, it has to be positive, right? So clearly, one root is going to be less than 1, the other root is going to be greater than 1, right? So option C, the statement is correct, which means option B is incorrect for us. T goes to half minus, then alpha t minus beta t approaches 0. So for this, you just need to find the difference of the roots. What is that going to be? T approaches half minus, then alpha t minus beta t approaches 0. For this, just observe that if t approaches half minus, okay, then this quantity is positive. This quantity approaches 0, right? But from the positive side. So this discriminant is going to be approaching 0, right? This implies that delta t approaches 0. Now, if delta t approaches 0, what does that mean? That the roots are going to be equal, right? So if the roots are equal, clearly the mod of that difference is going to be approaching 0, right? So option D has to be correct for us, okay? So option D is also correct, right? Okay. Coming to the next one. So for the next one, you want to find the real and the imaginary part of the complex number 1 plus root I. First of all, you need to find out what root I is, okay? So if I consider that there is some complex number a plus ib, which is equal to square root of iota, then I know that a square minus b square plus 2ab iota should be equal to iota, right? Just squaring both sides, which implies that a square minus b square is 0, which means mod a is equal to mod b, or rather a is equal to plus or minus b. And from the second one, I get that ab should be equal to half. So if a is equal to b, you'll get that a equal to b equal to, right? And a is equal to minus b would imply that minus a square is equal to half, which is again not possible for us, right? Because a and b by default, they are real numbers, right? So this is not allowed. So you'll get that the only two solutions from here are 1 by root 2, 1 by root 2, or minus 1 by root 2 and minus 1 by root 2, right? So what does this number look like now? This is basically 1 plus a plus iota b. So that is going to look like 1 plus root 2 plus iota 1 by root 2, right? Or it's going to look like 1 minus 1 by root 2 minus iota by root 2, right? So which are the possible options that are correct? So 1 minus 1 by root 2 and minus 1 by root 2, yes. Minus plus not allowed. Plus plus allowed. Plus minus not allowed, right? So A and C. So these are the two correct options for us, okay? Simple, straightforward one. Alright, if you look at the next question, you have to find the sum of the real and the imaginary parts of this number, okay? So first of all, observe that for any number, okay? So sine theta minus iota cos theta, this can be written as, if I take minus iota common, I get what? Cos theta plus I sin theta. I can write it like this. Yep. So this quantity just turns out to be summation p equal to 1 to 32 3p plus 2 times summation of q equal to 1 to 11. The minus iota that you take common from here, okay, if you take that outside, it will become minus iota to the power p, and the summation is independent of p, right? So I can take it outside, so I can write it as minus iota power p times summation of this. This will become sine 2q pi by 11, sorry, this will become cos of this plus iota sine 2q pi by 11, right? This whole to the power p. Now observe, this is nothing but the sum of the 11th roots of unity. Right? Even though it starts from, it's supposed to start from 1 plus whatever, so on and so forth. See, when you put q equal to 11, this is going to give you 1, right? Okay, so that's the idea. So overall, this is the sum of the 11th roots of unity, okay? And we know that the sum of the 11th roots of unity is going to be 0. So if this quantity is 0, this overall expression turns out to be what? 0. What is the sum of the real and imaginary parts of 0? 0. So the answer is A, okay? Clear? Alright, moving on. So you have ABC are angles of a triangle ABC, then what is the value of this determinant, okay? First of all, observe that if I take e to the power iota 2a common from the first column, okay? If I take e to the power minus iota c common from the second one, so this will become minus c. And if I take iota b common from the third column, this entire determinant looks something like this, right? This times, this will become 1, 1, 1. Second one is going to be e to the power minus iota. You're taking this, right? So minus iota c minus 2a, right? Plus 2a, sorry. C plus 2a, sorry, minus minus, yeah, iota c plus 2a cancels out, fine. This one will become e to the power minus iota b plus 2a. Similarly, this is going to be what? Second column, 2b plus c, right? It's going to be e to the power iota. You're taking b common from here, right? That's iota. Iota a, you took b common, right? So minus iota b plus iota b you want, right? Okay. Similarly, for the last two entries, what will you get? You'll get e to the power minus iota a minus c, right? E to the power iota 2c. You're taking minus b common, right? So minus b plus b, you want it over here. Okay. So once you take these terms common, this is what you'll end up with, right? This is what your new determinant looks like. Okay. Right. Now, if I use the angle sum property, observe that after this, all we'll do is use the fact that a plus b plus c has to be equal to pi, right? Okay, because these are angles of a triangle. Okay, so this is what you'll get. Now, if I look at all the terms individually, observe what do I get. Okay, so if I look at the first term, 2a minus c plus, sorry, 2a minus c minus b, right? Okay, so 2a means add a on both sides, subtract 2c, subtract 2b, right? So you'll get pi minus, or let's just go with the individual terms here first. Okay, let's come to this overall term later on. From here, you'll get c plus 2a, right? Which means c and you have to add a, right? So c plus a, that's 2a. That should be equal to pi plus a, right? And this minus b. So pi plus a minus b you'll get, okay? Right? Fine. Similarly, for the second one, 2b plus c. Now see, e to the power minus iota times this, right? What can I rewrite this as? Right. So if I plug this here, this first term, if I just look at the first term, what will I get? I'll get minus iota times pi plus a minus b, right? Which can be written as e to the power minus I pi times e to the power minus iota times a minus b, right? So this thing, e to the power I pi is equal to minus 1, right? So e to the power minus iota pi should also be equal to minus 1, right? This is also going to be minus 1. So this overall quantity just turns into, so if I write this as a new determinant, so the first row was 1, 1, 1. Second term is going to be minus e to the power iota b minus a. So I can just write this as iota b minus a, right? Okay. Similarly, coming to this term, 2b plus c, what will that be? Let's see. So from here, 2b plus c should be equal to pi plus b minus a. So by the same argument, what will you get? You'll get a minus 1 because of iota pi. Okay, you'll get minus 1 times e to the power b minus a. Okay, right? You get the same term. Third one, e to the power minus iota times a minus b, right? If I just take this minus sign outside, this is nothing but e to the power iota times b minus a. Right, so this entire column, okay, sorry, this entire row, you can see that you have this term that's common, right? E to the power iota b minus a. Similarly, if you do it for the third row, okay, in the same way, you'll see that all these terms will be minus plus minus e to the power iota c minus a, okay? Okay, by the same logic, okay? And what was the term outside that you had? E to the power iota 2a minus b minus c. Clear? This is what we have, right? So there's no minus, sorry. There'll be no minus, just e to the power iota times this. Okay. Now again, I can take this iota, e to the power iota b minus a common from the second row and this common from the third row. Then what will I end up with? I get e to the power iota times 2a minus b minus c. From here, you're going to add b minus a. And from the third, you're going to add c minus a. So this just turns out to be what? 2a 2a cancels out, b cancels out, c cancels out, right? So this gives you 0. So e to the power 0 is just 1, right? So this quantity just turns out to be 1. And the rest of the determinant is going to look like 1, 1, 1, minus 1, minus 1, 1. And the third one is minus 1, plus 1, minus 1, right? Okay? So this is a simple determinant, right? Now you can just expand this and find the determinant of this. And if you do, you'll see that it turns out to be how much? 1 times minus minus plus minus 1, 0. 1 times 1 minus minus plus 1, right? So 2. And for this third one, sorry, minus 2. For the third one, 1 times minus 1 minus 1 is plus 1, 0. So you get minus 2, right? Okay? Wait, 1 second. Let's expand this and see. So you'll get 1 times minus minus plus 1 minus 1, right? Second one, you get minus 1 times minus minus plus 1, right? Minus minus 1, right? So another plus 1, right? And for the third one, what are you going to get? Plus 1 times minus 1 minus minus plus 1. So minus minus, again minus 2, right? So you get minus 2, so minus 4, right? Okay? So that is the answer, okay? So what is the value of this determinant? Minus 4. Okay? A little calculative, but the idea was very simple, okay? All you had to do was use the fact that because they're angles of a triangle, you get a plus b plus c is equal to 180, right? Now after that, you just have to simplify this determinant, okay? So that is question 9. Coming to question 10. The number of terms that are integers in the binomial expansion of this is what? Okay. So what is the general term going to look like? Remember, for any question like this, what do? You find the general term. So it's going to be n choose k. 7 to the power 5. Sorry, let's go with k by 2 times 5 to the power 2025 minus k divided by 3. Right? This is what you're going to get, where k ranges from 0 to 2025. Okay. Now observe that 2025 is divisible by 3, right? 5, 6, 7, 8, 9, right? So you want 3 to divide k and you want 2 to divide k, right? So basically for this to be an integer, you want 2 to divide k and you want 3 to divide k, which means 6 has to divide k, right? So all you have to do is look for the number of multiples of 6 in the range k equal to 0 till 2025. So what are you going to get? It's going to be box of 2025 by 6 plus 1, right? Okay, because 0 is also included, okay? So this is going to be what? Sorry, by 6. So box of 6, 2s are 12, so 6, 3s are 18, 2, 6, 3s are 18, 2, 4, 6, 42 point something, right? So that's going to be 337 plus 1, and this extra 1 is because of 0, right? So in this multiples, we don't really count 0. So you have to add 1 to it, so overall you get 338, right? Okay, so that is option D, right? Okay. All right, so let's look at the next one. So if this summation is equal to this summation and ak is equal to 1 for every k greater than equal to n, then what is the value of bn divided by this, okay? So first of all, observe that we can rewrite this as, if I write x minus 3 equal to, say, some t, okay? Then your left hand side will look like what? This is nothing but t plus 1, right? So you get ar t to the power, 1 plus t whole to the power r. That should be equal to summation of br t power r, right? R equal to 0 to 2n, r equal to 0 to 2n, right? Now observe that you are looking for bn, right? What exactly is bn? So among all the terms in this right hand side, bn is going to be attached to t to the power n, right? Right, so you just have to find the coefficient of t to the power n on the left hand side. Now observe that if this r is less than n, okay, if r is less than n, then none of these expansions can contain t to the power n, right? Very simple and obvious fact. So you only have to look at terms which are greater than, you have to look at terms where r is greater than equal to n, right? And observe that it's given that ak is equal to 1 for every k greater than equal to n, right? So basically in this expansion, you're only concerned with terms that start with, so it's going to be 1 plus t whole to the power n plus 1 plus t whole to the power n plus 1 all the way till 1 plus t whole to the power 2n. Right? So in this entire sum, what is the coefficient of t to the power n? It's going to be n choose 0, right? You can just write it, or rather n choose n, whatever you want. N choose n plus 1 choose n all the way till 2n choose n, right? Yep, this is what you'll get. Now observe that this can also be rewritten as, just for the simplicity, you can write as n choose 1, n choose 0, n choose 1 all the way till, n plus 1 choose 1. 2n choose n, right? Now observe that the sum of these two, what is n choose r? What is n choose r? plus n plus 1 choose r plus 1. What is this going to be? See, n choose r plus n plus 1 choose r is nothing but n plus 1 choose r plus 1, right? Sorry. N choose r plus 1 is n plus 1 choose r plus 1, right? We know this, okay? The only trick in this question is, instead of writing it as n choose 0, let's write it as n plus 1 choose 0. So observe that the first two terms are what? N plus 1 choose 0, n plus 1 choose 1, right? Which is nothing but n plus 2 choose 1, right? Now see, the next term was what? N plus 1 choose 1, and the next term is going to be n plus 1 choose 2, right? So this plus the next term, which is n plus 2 choose 2, these two will combine to give you n plus 3 choose 2. Similarly, the next term after that is n plus 3 choose 3, right? So that will give you n plus 4 choose 3, and so on and so forth. So if we continue this way, you'll see that this precisely turns out to be equal to 2n plus 1 choose n plus 1, okay? Ultimately, because you have this n here, the previous term is going to be 2n choose n minus 1, right? Which will add up to give you 2n plus 1 choose n plus 1, right? Okay? Wait 1 second. So by the same logic, if I induct on this, what will I end up with? So this is going to be 2n choose n minus 1. So this and this will add up to give you 2n plus 1 choose n, right? And 2n plus 1 choose n is precisely 2n plus 1 choose n plus 1, right? So what is this ratio going to be? Just 1. Okay? That's it. Clear? All right. Okay, so coming to the next question. Find the coefficient of x to the power 50 in this expansion. First of all, one thing you need to understand about this is nothing but a AGP, right? So let's find the sum of it. So S, if I write it as last one is 1001 x to the power 1000, right? So what is the common ratio for the C? The common difference for the AP part of this is nothing but 1, right? You're adding 1 at every step. But the common ratio that you're taking is nothing but R equal to, you're multiplying by x and dividing it by 1 plus x, right? So I multiply this, so I can write that Sx by 1 plus x is going to be nothing but, and shifted by 1 step, okay? So this is going to be what? X to the power times 1 plus x whole to the power 999, right? Plus next one is going to be x square 1 plus x whole to the power 998. All the way till this term is going to be 1000 times x to the power 1000. And the last term is going to turn into what? If you look at the last term, if you multiply it with x, it will become 1001 divided by 1 plus x. So the difference of these two, so s times 1 minus x by 1 plus x is going to look like, so this first term remains, second term is going to become what? If you subtract this, you'll just get 1 plus x whole to the power 999. All the way till the last one is going to just be, wait 1 second, it's going to be, x times this, right? Till x times 1000 minus, okay, fine. Now what I can do is I can multiply both sides by 1 plus x. This will basically turn into 1 plus x minus x is just 1, right? So s is nothing but 1 plus x whole to the power 1001 plus x times 1 plus x whole to the power 1000 all the way till x to the power 1000 times 1 plus x minus 1001 x to the power 1001, right? Now observe that ultimately in the end you have to find the coefficient of x to the power 50 in this. Now obviously this does not contribute to that, right? The power of x itself is 1001, so we don't care about this term. So all we need to do is evaluate the sum of this particular GP, right? So if I find the sum of this GP, what will I get? First term, R is what? X by 1001, sorry, x by 1 plus x, right? So R, what are the number of terms in this GP? Starting from 0 all the way till 1000, right? So there are 1001 terms in this. Yep, there are 1001 terms in this, right? So this will become 1002 minus 1 divided by x by 1 plus x minus 1, right? So that will give you times, this will become x to the power 1002 minus, let's just go with the opposite. I mean, it doesn't really matter, okay, either way. And let's just switch sides, okay? So this will become 1 plus x whole to the power 1002 minus x to the power 1002 divided by 1, right? 1 plus x minus x, so yeah, just plus 1, okay? Sorry, plus 1. And over here you'll have this x to the power 1002 left, right? And that multiplied with 1 plus x just gives you this. This and this cancels out. So ultimately you have to find the coefficient of x to the power 50 in this. This does not contribute again. So what is the coefficient going to be? 1002, choose 50, right? That is the coefficient of x to the power 50 in this entire sum, all right? And that is option C for us, okay? So the right answer is option C. Clear? So it looks complicated, it looks messy, but ultimately it just boils down to finding the sum of a particular GP, all right? Okay, clear. Let's look at the next one. So you have alpha and beta, the roots of the quadratic ax square plus bx plus c equal to 0, and you have defined the typical discriminant. If these three quantities are in GP, then which of the following is true? So if these three quantities are GP, that means alpha square plus beta square whole squared is equal to alpha plus beta plus alpha cube plus beta cube, which is nothing but alpha plus beta times alpha square plus beta square minus alpha beta. Alpha square plus beta square is what? Alpha plus beta whole square minus 2 alpha beta. This quantity whole squared should be alpha plus beta whole squared times, again this thing is same, alpha plus beta whole square minus 2b minus 2b, so minus ab, so 3 alpha beta, right? Now if I plug the values, what is alpha plus beta? It's minus b by a, right? So this becomes b square by a square minus 2c by a whole squared. That should be equal to alpha plus beta, okay, again, so b square by a square times this will be b square by a square minus 3 times c by a, right? So observe that if I simplify this, you have a to the power, you'll get what? 1 by a square, so 1 by a to the power 4 times b square minus 2ac whole squared equal to b square by a to the power 4 from here and b square minus 3ac, right? So this cancels out, you're left with this, okay? Again, if I simplify this, what will I get? I get b to the power 4 plus 4a square c square minus 4b square ac. That should be equal to, again, b to the power 4 minus 3 ac b square, right? This and this cancel out. Send this term to the left hand side. What will you get? Or bring it to the right hand side, yeah. You'll get b square ac minus 4 a square c square equal to 0. And if I take, say, ac common from here, now we know that a can't be 0 because a is the leading coefficient, right? Which means c times b square minus 4ac should be equal to 0, which means c times delta should be equal to 0, which is option C, okay? As simple as that, all right? Just plug in the values using Veta and then solve it, okay? That is all this question has to do. All right, let's look at the next one. So 2 unit squares are chosen randomly from a standard chessboard. What is the probability that 2 squares have exactly one corner in common? So one thing you need to understand, for 2 squares to have exactly one corner in common, they need to be diagonal squares, right? These are the only squares that share one corner in common, right? Either this orientation or it could also look like this, right? Something like so. These are the only squares you're looking for, right? Now observe that you're choosing 2 squares, right? So your denominator is fixed. It's nothing but 64, choose 2, okay? Now observe how many such squares can you choose. See, the idea is very simple. If you picture a standard chessboard, see, if you're looking at squares that look like this, okay, in the first row, okay, if I start with the first row, this is one possibility. Second possibility is going to be this and this, right? This goes on all the way till the second last one, right? Suppose this is the last square. This is what you can choose, right? So you have 7 options, right? So in the first row, you have 7 options. And this goes on again till the second last row, right? Because you can't go to the last row, obviously. So this, right? All the way till the same idea. So 7 in the first one, all the way till 7 in the last one, right? So how many such squares are you getting? 49, right? Okay, 49 for this orientation. Similarly, I can do the opposite as well. I can start from here. Again, you'll get 7 times 7, right? So 49 times 2 is the total number of favorable squares that you can choose, right? Divided by 64, choose 2. So that's 64 into 63 times 2. So 7, 9, 16. So that's basically 7 by 144, right? So that's option B for us, okay? As simple as that, okay? So all you had to do was picture how a standard chessboard looks like, okay? So the final answer is 7 by 144. All right. Coming to the next one. a fair coin is independently flipped n times, out of which x is flipping it k times and y is flipping it n minus k times, then what is the probability that x and y obtain the same number of heads, okay? So overall you are flipping the coin n times total, right? Out of which k times it's done by x and n minus k times it's done by y, right? Now you want that they get the same number of heads, okay? So this value could be anything, right? It could be I, so number of heads, if I talk about the number of heads that they get, if I say that it's equal to some I, then I can range anything between 0 all the way till the minimum of k and n minus k, okay? Now observe, this question is very simple, okay? You don't even have to calculate anything. Assume that x is getting some I heads, okay? Then y also needs to get I heads, okay? So you need to find the probability okay? Now see, if x is getting I heads, okay, then x is going to get k minus I tails, right? Out of the k tosses, if it's getting I heads, then n minus I have to be tails, right? So this is the same as the probability x gets now the key step is here. If x gets n minus I tails, because it's a fair coin, in any fair coin, the probability that you get n heads is the same as the probability you get n tails, right? Both of them are equal to half to the power n, right? So the probability that x gets n minus I tails is nothing but the probability that x gets n minus I heads. These two are again the same. And you want y to get I heads, okay? Clear? Okay? And probability that x gets n minus I heads and y gets I heads is the probability that you get, sorry, this is going to be k minus I, right? Yeah, my bad. This will be k minus I, this will be k minus I. So probability that x gets k minus I heads and y gets I heads is the probability that you get k heads, right? Yes or no? And the probability you get k heads is what? Out of n, k divided by 2 to the power n, right? So that is your required probability. So that's n choose k divided by 2 to the power n. That's it. You don't even have to calculate anything. Just use the idea of probability and the concept of a fair coin, okay? That's all you need to do in this question. Alright, coming to the next one. So a student appears for test 1, 2 and 3. The student is successful if they pass in either test 1 and 2 or test 1 and 3, okay? Then the probability that the student is successful, okay, the probability that the student is successful in passing these tests are p, q and half respectively. And it's given that if the probability that the student is successful is half, then find the value of this expression, okay? So observe that what are the cases? See, one case is if the student passes all the 3 exams. That's simple, right? So 1 and 2 and 3, that's the best case scenario, right? The student passes in all the 3 exams. If not, if the student is failing one subject, then for the student to successfully pass, or rather for the student to be successful, what are the other 2 cases? So it's either 1 and 2. So he's not passing all the 3, right? Which means he's failing in C, right? If I write it as 1 and 2 and 3 complement, I can write it like this, right? So he passes in exams 1 and 2 and fails in 3, or the other cases, he passes in 1, fails in 2, and again passes in 3. So these are the only 3 cases in which the student is successful. So what is the required probability? The sum of these 3. And again observe that these are all independent tests, right? So the probability of the first one is PQ times half, so PQ by 2, plus this is going to be PQ times half minus half, so again PQ by 2, plus this is going to be P times 1 minus Q by 2, right? And this entire expression is equal to half, we know, right? So if I add these 3 terms together, what will I get? This implies that PQ plus PQ plus P minus PQ is equal to 1. This and this will cancel out. Take P common, you get 1 plus Q. That is equal to 1. So the value of this expression is nothing but 1. As simple as that, okay? Right? Okay. Alright, let's look at the next one. So you have an ellipse omega, and F1 and F2 are its 2 foci, and P is a point on the circumference which is neither on the major nor the minor axis, right? If P F1 intersects omega again at some point Q, and Pf2 intersects omega again at some r which is not P, then which of the following is true? Okay, so this is very simple. Okay, all you need to do is draw the figure. So if I draw a random ellipse, it's going to look something like this, right? And you're choosing a random point P which is not on the major or the minor axis, right? So now let's say this is F1. So it intersects again at a point Q, right? So this is our point Q. The other one, let's say this is the other foci, F2. So it intersects at R, right? So you're talking about triangles P, F1, R, right? So you have to talk about this and this other triangle, okay? So you have to talk about this perimeter. Now observe that the perimeter of this triangle P, F1, R, it's a perimeter of this. This is nothing but Pf1, right, plus F1R plus PR, right? Now this PR can again be broken down as Pf1, so F1R plus PR is going to be what? Pf2 plus F2R. Now what do I know? From any point, the sum of the distances to the two foci, this is a constant and it's equal to twice the length of the major axis, right? Assume it's 2a. So this and this add up to give you 2a. This and this will add up to give you 2a. So this perimeter is 4a. And you can see this is clearly independent of the choice of P, right? So the same thing if you do it for the other triangle PQF2, same idea. So this plus this is 2a, this plus this is going to be 2a. So overall the perimeter is 4a, right? So no matter what your triangles are, no matter where point P lies, these are always equal. Perimeters are equal if and only if F1, F2 is parallel to this. Incorrect, right? It's always true. Perimeters are not equal, obviously that's also going to be incorrect. The lines F1, F2, QR are always parallel, no. For a random point, it's not going to be. For a point on the major or the minor axis, it would have been true, right? Okay. But for any random point, it's not going to be true, right? So D is also incorrect, okay. So the only correct option is option A for us, alright? Cool. Coming to the next one. You have defined a function from n to z, which is epsilon minus 1 by 2 and minus epsilon by 2, okay. So observe that if you just look at where these maps all the epsilons, okay. So for 1, it's going to be 1 is odd, right? So 1 gets mapped to 0. 2 is even, so it's going to get mapped to minus 1. 3, it's going to get mapped to 3 minus 1 is 2, so plus 1, right? 4 is going to be mapped to minus 2, and so on and so forth, right? So I clearly see the pattern, right? It's 0, minus 1, plus 1, minus 2, minus, so next one is going to be plus 2. Then minus 3, plus 3, so on and so forth. So clearly it's both 1, 1 and on 2, right? It takes care of all the integers, it's also 1, 1, right? So it's both 1, 1 and on 2. That's it, okay? So you'll also get a couple of questions like this, okay, which are going to be very simple and straightforward. Just write down where the function is mapping all your values to, and you'll understand which of the options is correct, okay? Okay, so the next one is, for every integer m and n, we define a function f m comma n from z to z, which is this linear function, okay, mx plus n. Now you look at the collection of all such functions, that is our capital F for us. Now an element is said to be invertible if there exists another function g such that f of g of x is equal to g of f of x is equal to x, right? Then which of the following options is correct? So for this, observe that if I take f to be, say, ax plus b, and I take g to be cx plus d, then what are the compositions going to be? So f of g of x is going to be a cx plus ad plus b, right? Similarly, g of f of x is going to be again acx plus, now it's going to be cb plus d. And you want both these values to be equal and they need to be equal to x, okay? So the simplest thing is, you want this coefficient to be 1 for both of them. So you want ac equal to 1 and they're integers. So a equal to c equal to either plus 1 or minus 1. I can just take, for the sake of simplicity, a equal to c equal to 1, right? Now if you take a equal to c equal to 1 and suppose I choose b equal to minus d, then look at these constants. A is equal to c, so this is going to be, see, this is going to be 1. Okay, they are both equal to 1, so this becomes b plus d, and the b plus d sum is equal to 0. Same here. So both of these are equal and they're both equal to x, right? So any function that looks like this, okay, any x plus n, you can find a corresponding x minus n, and these are both invertible, they are both inverses of each other, right? And now you have infinitely many choices for n, right? Because you are working over the set of integers. So you can clearly see that it has infinitely many elements which are invertible. Obviously for any other function, it's not going to be invertible, right? If I just choose a to be equal to 2 or something, it's not going to be invertible, right? So we can clearly see that capital F has infinitely many invertible and infinitely many non-invertible elements. So option B is correct for us, okay? Simple, right? Just a very simple construction and then looking at this, okay, that you want both of them to be equal to x. All right. Cool. Go to the next one. So you have a subset of R, you're defining a function from A to R such that f prime x is equal to 0 for all x in A. And which of the following is true? Okay, so this is a question where you have to come up with simple counterexamples, okay? F is a constant function. That's not necessarily true, right? I can simply construct a function which is, say, 1, okay, in between, say, 2 and 3. And between 3 and 4, it's equal to 2. Okay, mind you, I'm choosing my intervals to be open 2, 3 and open 3, 4. So in this case, my set A is nothing but 2, 3, union 3, 4, right? So this points 3 and 4, the points where you might think that it's not continuous, these are not even included in the domain, right? So it's clearly differentiable and the derivative is 0, right? So it doesn't have to be constant. F is never a constant function, that's obviously incorrect, right? Every constant function is going to be satisfying this, okay? So V is also incorrect. C, F can take at most 2 distinct values. That's not true, right? I can just add another interval after this, say 4 to 5, and I can extend it further, right? It can take as many values as it wants, okay? So F doesn't, there's no necessity that it needs to take exactly 2 distinct values. So what is your final answer? Then none of these are true, okay? They're all incorrect statements, okay? A very simple counterexample, okay? And you'll see that there are a lot of questions in nests where they actually ask you to think of simple counterexamples to particular options, okay? So you should be able to come up with simple ideas like this, okay, during the exam. Fine? All right, moving on. All right, so let's look at the next question. So the next one is, suppose alpha is defined as limit n going to infinity cos pi by 4 cos pi by 8 all the way till cos 2 to the power n plus 1, right? Then find the value of this limit, okay? So observe that this can be written as limit n. Let's just calculate this product first, okay? So you have cos of, so this is basically cos of pi by 2 square times cos of pi by 2 cube all the way till cos of pi by 2 power n plus 1, right? This is what I have, and I need to find the limit of this as n approaches infinity, right? Okay. Now observe that we have cos terms, right? If I somehow get an extra sine term, I'll be done, right? So let's just write this as some expression. Let's just go with some beta or something, okay? So I can, let's go with, say, n, okay, xn. So you can see that xn times sine of pi by 2 to the power n plus 1, this is going to be nothing but cos of pi by 2 square all the way till cos of pi by 2 to the power n plus 1, right, times sine of pi by 2 to the power n plus 1, right? Okay. Now, if I multiply this by 2 and divide it by 2, so half times, if I multiply this 2 over here, then this term is going to be nothing but sine of pi by 2 power n. And the term right before this is going to be what? Cos of pi by 2 power n, right? And the rest of the thing. So once again, if I multiply and divide by 2, so this is going to be 1 by 2 square times twice of this. So again, this will turn into just this part. This term is going to be sine of pi by 2 power n minus 1. And if I keep on doing this, if I constantly multiply this, in the end, what will I be left with? So I can go on all the way till sine of pi by 2, right? So in the end, it will be some power of 2. We'll figure out what the power is. You'll be left with ultimately sine of pi by 2. Okay. Now observe that this, the power of 2 here and the power of 2 in the denominator, if you look at their sum, it's going to always add up to n plus 1, right? For example, over here. So in this case, if you forget about this, just here, okay, when you multiply it by sine, this was 1 by 2 power 0, 2 power n plus 1. So ultimately the power here should be 2 power n plus 1, right? And this quantity is just 1, right? So I can say that xn times sine of pi by 2 power n plus 1 is nothing but 1 by 2 power n plus 1, right? Okay? Which means xn is nothing but power n plus 1, right? Now if I multiply it and divide by pi, okay, so what am I looking for? I'm basically looking for limit n going to infinity xn, right? So alpha is nothing but limit n going to infinity xn, which should just be, okay, so pi, take this 2 power n plus 1 here, divided by, so you have to divide by pi because you're multiplying by pi, okay, so sine of pi by 2 power n plus 1. Now see, as n goes to infinity, this quantity approaches 0. So sine h by sine h, the limit we know it goes to 1, right? So what is the value of alpha? It's 1 by pi, okay? Which is option. ये वाला question काट देना पूरा, ठीक है? Okay. So coming to the next question. So let alpha be limit n going to infinity cos pi by 4 cos pi by 8 all the way till cos pi by 2 power n plus 1, then find the value of alpha. Okay. So consider this product. Okay. Consider the product till the nth term to be some xn. Okay. So this is cos pi by 4. So that's basically pi by 2 square. Then 2 cube all the way till cos of pi by 2 power n plus 1, right? So from here, if I multiply both sides by, say, sine of this quantity, so xn sine of pi by 2 power n plus 1 is going to be the entire cos product times sine of pi by 2 power n plus 1, right? Times cos of pi by 2 power n plus 1, right? Now if I multiply and divide by half, okay, this quantity is now going to turn into, so this entire thing, so xn sine of pi by 2 power n plus 1, so half this is going to be sine of, so there will be a cos of pi by 2 power n here times this is going to turn into sine of pi by 2 power n. Okay, once again multiply by 2, divide by 2, right? So if we keep on doing this, every step you multiply by 2, right? You get the double angle. Okay, so in the end what are you going to left out with? Ultimately you will go all the way till, so you can say that xn sine pi by 2 power n plus 1 is going to be 1 by 2 power how much? So you can see that this, if you forget about this first step, okay, it was this, this was this, right? Okay, so if you have 2 power n here, you can see that the power should add up to n plus 1, right? If you have n here, you have 2 power 1. When you have n minus 1, you have 2 square and so on and so forth, right? So this power of 2 and whatever is left inside, right? So if I take sine of pi by 2 power, sorry, pi by 2, right? Then this is power 1, so here the power should be 2 power n, right? And this is equal to 1, okay? So from here I can say that xn is nothing but 1 by 2 power n sine of pi by 2 power n plus 1, right? So now what is alpha for us? Alpha is nothing but which is limit n going to infinity 1 by 2 power n sine of pi by 2 power n plus 1, right? So what I can do is multiply and divide by 2. So you'll get 2 power n plus 1 and multiply and divide by pi, okay? So now this is precisely this, right? And as n goes to infinity, I know that pi by 2 power n plus 1 is going to approach 0. So sine h by h as h goes to 0 is 1, right? So what are we left out with? This 2 by pi, right? So this alpha is nothing but 2 by pi. So the right answer is option A, okay? Clear? So that's question 20 for 1 for us. Alright, coming to the next question. This function, okay, so this function is a special function. This is just in case you get questions which ask you for counter examples, okay. This function is known as the Weierstrass function, okay. And what is the speciality of this function? This is a function which is continuous everywhere and it's differentiable nowhere, okay. Continuous everywhere, but differentiable nowhere, okay. So remember this, okay. And the proof is way beyond the syllabus, but just for the sake of the exam, in case you get questions like this, if they ask you for counterexamples, so there are functions which are continuous everywhere and differentiable nowhere, right? So which of the following is true? Continuous everywhere, yes. There is just some zeta such that this is discontinuous at this. No, it's not, right? Because it's continuous everywhere. Differentiable everywhere, wrong. Finitely many points where it's non-differentiable, that's also incorrect, right? Because it's differentiable nowhere, right? So the only option that's correct is option A for us, okay? So remember this, think of it as a conceptual fact, all right? If you look at the next one, you have a function from 0, 3, union 6, 9 is a differentiable function such that f prime x is equal to half for all the values in this interval, right? So if f prime x is equal to half, if I plot the graph of this function, it's very easy to draw it, right? So you'll have, so 3, 0 to 3, right? So in this interval, if f prime x is equal to half, then your function looks something like this, right? Obviously, this endpoints are not included, okay? Similarly, from 6 to 9, again, you'll have something that looks like this, okay? So your function basically looks like x by 2 plus some constant. Okay, there could be a constant, we don't know. Okay, I'm assuming in this case for this diagram that the constant is 0. But if there's a constant, it just shifts upward or downwards. Okay, that's the idea. So the graph should look something like this. Okay. So now if you look at the option, f is an increasing function, that's incorrect, right? Because after this point, if I look at something near 6, it's decreasing, right? The value decreases from here till here. So it can't be an increasing function. It's a 1-1 function, again, incorrect, right? There are lots of points where it's not 1-1, right? F of 8 minus 7 is equal to f2 minus f1, okay? Is this going to be true? Yes, right? Because if you observe that these are both at distance 1, right? If you just look at the slope of this, f8 minus f7 divided by 1 is nothing but the slope of the line joining those 2 points. Similarly, this is the slope of the line, and these slopes are both equal to what? Half, right? Yep. So both of them are going to be equal. So C is correct, okay? There exists a number c such that fx plus 6 is equal to fx plus c for every x in 0, 3. This is true, right? If you think about it, it's kind of periodic, right? So if you look at this point, if you add 6 to it, it's true, right? I mean, what is the value of c actually? C is just going to be 0, right? If you add 6 to any point, I mean, if you add c to any point, okay? Actually, it doesn't really matter. It could also be like this, that over here you have a value of c1. Over here, the value of this constant is different, right? It could be that over here it looks something like this, and here you shift it upwards, right? So that is a possibility. So, but they'll only differ by a constant, right? So option D is also correct, okay? So right answers are option C and D. Fine? Clear? Okay. Coming to the next one. You have a function that's defined as limit n going to infinity, summation of box of kx, okay? So if I just look at this, so fx going to infinity, summation of box of kx, k from 1 till n divided by n square, right? Now what do I know about box x? So box of kx is going to be bounded by, say I bounded between, what should I bound it by? Or do I need to bound this? Let's just go with this, okay? This can be written as limit n going to infinity. Box x is what? X minus fractional part of x, right? So this can be written as summation of kx by n square minus 1 by n square summation of fractional part of x, sorry, fractional part of kx, right? Okay. Now observe that just this quantity, this first limit, that can be easily calculated, right? It's going to be x into n plus 1 by 2 n square, which just gives you x by 2, right? For the second one, observe that this is bounded by how much? It's bounded by n and bounded by 0, right? We know that fractional part of kx is going to be between 0 and 1, which means this entire sum is going to be bounded by n and it's going to be greater than or equal to 0. So this by n square is going to be bounded by 1 by n and 0. And if you take limit n going to infinity, see, by Sandwich theorem, it's going to converge to 0, right? So you can directly say, this is what you are getting, which means that fx is nothing but x by 2. As simple as that, okay? Right, if fx is equal to x by 2, fx is increasing only in the positive reals, that's incorrect, right? Okay, that's obviously incorrect, right? It's increasing everywhere. Fx equal to x by 2 is a strictly increasing function over all real, right? So because of this only in, this option is going to be incorrect, right? Second one is f prime x is increasing. F prime x is just half, right? So it's only increasing. Technically, half is also a non-decreasing function, right? And we always know when we say increasing, we mean we allow equality, right? Okay. So is it only increasing in 0, infinity? That's also incorrect, right? It's also increasing everywhere. F of x plus y is equal to fx plus fy. Yes, this is going to be x plus y by 2. This is going to be x by 2 plus y by 2. So they are both equal, right? So C is correct, right? Option D is f prime eta is equal to half for finitely many values. No, right? It's equal to half for every value, right? So this is also incorrect. So the only option that's correct is option C for us, right? Okay. So ultimately it boils down to a very simple function, but the thing was you had to find this limit first, okay? Cool. All right, so let's look at the next question. Again, it's a question where you have to find counterexamples, okay? So you have two functions. If x is an R, then g of f of x is continuous at x when, okay? So the first one is if both f and g are continuous at x, which is the condition for g of f to be continuous at x, right? So for the first one, observe that if I simply take, say, fx to be, let's just go with minus 1 if x is greater than or equal to 0, 1 if x is less than 0, right? So clearly you can see that this function has a discontinuity at x equal to 0. And let's say I take gx to be just mod of x, okay? then you can see that g of f of x is going to be identically equal to 1 for every value of x, right? It's a constant one function. So this is continuous, but for this to be continuous, we don't need both f and g to be continuous. You understand? So the first condition is not the correct condition, okay? So even if both f and g are not continuous, we can still have f and g to be continuous, okay? Okay, so option A is incorrect. If f is continuous at gx and g is continuous at x, okay? Right, is this condition sufficient? If I work with the same example, let's see what happens. F is continuous at gx, right? So we are checking continuity at x equal to 0, okay? So we're looking for continuity at x equal to 0. Then x is equal to 0, and at 0, g is continuous, right? G is continuous. Okay, g is continuous. F is continuous at gx. F is continuous at 0. It's not, right? F is not continuous at, what is the value of g of x? G of x is going to be just 0, right? Wait 1 second. Sorry, g of x is going to be 0, yeah. And 0, f is not continuous, right? F is not continuous at g of 0, which is equal to 0, right? But we still have f of g is continuous, right? So the same example works for option B as well, right? So this is not again the necessary condition. If and only if f is continuous at x and g is continuous at fx, okay? So for this, let's consider a different example. Say I go with the Dirichlet function, okay? 1 if x is rational and 0 if x is irrational, okay? And let's go with g, where let's go with g equal to this itself, right? Take g equal to f. Okay, then what is g of f? G of f, see, these two values are rational, right? So if you compose it twice, you're always going to end up with 1, okay? So g of f of x, again, it's identically equal to 1. Now condition, if and only if f is continuous at x and g is continuous at fx. That's not correct, right? At x equal to 0, we know that this function is continuous nowhere, right? Okay, but even then we still have f composed with g is continuous, right? Sorry, g of f of x. Okay, so again, this is not necessary. And the fourth one makes sense, right? If f is continuous, so we want f to be continuous at x and gx to be continuous at f of x, right? Because ultimately you're looking at g of f of x, right? So no matter what point you choose, you want g of f to be continuous at that point, right? So option D is correct, okay? Clear? So that's question 25. Coming to question 26. Okay. Coming to question 26. Which of the following options is incorrect? Okay. Fine, so if you look at option 1, if I consider a simple function, let's say we go with, say I go with f of x squared by x, okay? So this is option A, okay? Oh, sine of x squared by x, right? So f is differentiable. It's very easy to check that this function is going to be differentiable, right? If I look at the derivative of this, what does f prime look like? Sine will give you a cos of x squared. Sorry, yeah, cos of x squared times 2x by x, so that will give you a 2 plus sine of x squared by minus x squared, right? So the only point you're concerned with is x equal to 0, but at x equal to 0, this limit does exist, right? It's what? Minus 1 the second term. So this has its derivative, right? The question is, limit fx exists. Does limit fx exist? Yes, right? Because it's going to be bounded by what? 1 minus 1, so 1 by x and minus 1 by x, right? So at every point, it does exist, right? Or rather, as x goes to infinity, this is bounded, so this will go to 0, right? So this does exist, right? Then the question is, does limit x going to infinity f prime x exist? It doesn't, right? Even if this quantity goes to 0, we can't really make any predictions about cos of x squared, right? Because cos is oscillatory, right? So we can't predict what happens when x goes to infinity. So this is incorrect, right? So which of the following is incorrect? A is incorrect, right? So you can find one such function, okay? Second one is, if f is differentiable and bounded on 0 infinity, then f prime exists, okay? So for this, let's go with, say, sine of ln x. Clearly, it's a bounded function, right? And what about the derivative? Cos of ln x divided by x, right? It's differentiable. Is this differentiable on open 0 infinity? Yes, it is, right? We don't care about x equal to 0. We're working with open 0 infinity. So it's differentiable, right? This value does exist. Then limit x going to infinity, f prime x exists. That's, and this exists, right? We know what is the limit. So this is f prime, right? So limit x going to infinity, f prime is just 0 again. Then limit fx also exists. It doesn't, right? X going to infinity fx, again, sign is oscillatory, so this limit does not exist, right? So B is also incorrect for us, okay? If a function fx is differentiable at the point x equal to a, then the derivative is also continuous at x equal to a. This is option, okay? Is this correct? for this, if you just consider, let's say, x square sine 1 by x, we go with, so for option C, right, this is fx, right. See, as x goes to 0, this quantity is going to go to 0, right? That's clear. So if I look at f prime x, that's going to be x square cos of 1 by x minus 1 by x square plus 2 x sine 1 by x. Again, x sine 1 by x, it does exist, right? If you look at the point x equal to 0, clearly the derivative is not going to be continuous, right? Because 1 by x, as x goes to 0, 1 by x goes to infinity, right? This cancels out, right? So this will just cancel out, so it will be left with what? Minus cos of 1 by x minus cos 1 by x plus 2x sine 1 by x, right? So even though the second term, you know the limit is going to be what? 1, right? This first term, we can't really make any predictions about this as x goes to infinity, right? So even though the function is continuous at x equal to 0, its derivative is not going to be continuous at x equal to 0, right? So that is also incorrect, okay? Now remember, since we are working with incorrect options, we also have to check option D, right? So option D is if the derivative of a function is positive at the point x equal to a, then there exists a neighborhood about the point x equal to a where the function is increasing, right? Okay, so for this, it's slightly complicated, okay? So the function we'll consider is, if you consider something like, say, x plus 2x square sine 1 by x, right? When x is non-zero, and let's go with 0 if x is equal to 0, right? Okay, so clearly you can check that it's continuous. It's also going to be differentiable, right? What is the derivative going to be? It's going to be 1 plus, say, 2x square right? And this is what you're getting, right? So cos of 1 by x minus 1 by this, and this cancels out, okay? So as x goes to 0, you'll get 4. Yeah, okay. Right. Cos of 1 by x, so minus cos 1 by x, x going to 0. ये ऑप्शन डी से पहले वाला काट देना, ठीक है? Alright, and coming to option D, if the derivative of a function is positive at the point x equal to a, then there exists a neighborhood about x equal to a where the function is increasing, right? So for this, we have to calculate the derivative of this function, right? So suppose I take a function that looks like, say, x plus 2x square say sine 1 by x, okay? So this is my function where x is non-zero and it's 0 when x is equal to 0, right? So if I want to calculate the derivative of this function, see, at x equal to 0, how do I find the derivative? F prime 0 is going to be limit x going to 0, fx minus f of 0, right? So that's just going to be x plus 2x square sine 1 by x divided by x minus f0 is 0, so we can ignore it, right? So this just turns out to be 1 plus, what will you get from here? You'll get 2 x sine 1 by x, right? Which just goes to, well, look at x sine 1 by x, that's going to go to 0, right? So this overall just turns out to be 1, okay? So it is positive, right? The derivative is positive. But if you look at the neighborhood of this, right? If you look at the neighborhood of this function, can we make any predictions about whether the function is going to be increasing or not? If I look at this derivative, just normal, at other points, okay, non-zero points, it's going to be 1 plus 4x sine 1 by x, right? Minus, what will you get from here? You'll get 2x square cos of 1 by x. 1 by x square, right? So this x square and x square cancels out, so minus 2 cos x, right? 1 by x. Now if I look at the neighborhood of x, okay, you can clearly see that it's going to be something like 1 minus twice this cos term, right? Because this quantity is obviously going to go to 0. Okay, in the neighborhood of x equal to 0, right? Now I can always choose this value such that this overall quantity turns out to be negative, right? I can make f prime x less than 0, right? I can just choose this reciprocal 1 by x to be something such that cos of this turns out to be plus 1, right? In that case, the derivative turns out to be minus 1, right? Similarly, I can also choose it to be plus 1 depending on my choice of x, right? Both in the neighborhood of x, okay? So we can't really make any predictions about whether this function is going to be increasing or decreasing, right? So option D is also incorrect, okay? So all the 4 options were incorrect, and you saw some nice counterexamples for all these, okay? So remember these are counterexamples. Okay, look at the next question. So let R denote the set of real numbers, define the following function, then which of those following statements is true. So let's look at the differentiability, okay? So let's check the continuity first, okay? So if we check the continuity, obviously as x goes to 0, this quantity goes to 0, this goes to 0. So the function is continuous, right? This function is continuous as x equal to 0. Now for differentiability, if I look at the left hand derivative, it's going to be 2 minus 2x square minus x square sine 1 by x divided by x, right? Sorry, minus 2 divided by x, right? Because f of 0 is 2 for us. So when I divide it, see, you'll get a minus 2x term here, and you'll get a minus x sine 1 by x term, right? So no matter whether you look at the left hand derivative or the right hand derivative, in both the cases, this quantity is going to go to 0, right? So from here, we can say that it's differentiable and f prime 0 is equal to 2. So the first statement, the function is not differentiable, is incorrect, right? So option A is incorrect for us. The second is, see, for both part 2 and part 3, right? If you look at this function, if I simplify it slightly, I can write this as 2 minus x squared times 2 plus sine 1 by x. Now clearly, because of the sine component, you understand that it's going to be oscillatory, right? And any oscillatory function can't be a monotone function, right? No matter what interval you take, okay? So it can neither be increasing nor decreasing, right? So option B is incorrect, but option C says it's not an increasing function, which has to be true, right? So option B is incorrect and C is correct, right? Option D, x equal to 0 is a point of local minima of f, okay? So what is the value at 0? It's equal to 2, right? Now if I look at slightly towards the left hand side, okay, you can see that it's 2 minus some quantity. Now see, this part is going to be positive, right? Because sine is bounded by 1 and minus 1. So x squared 2 plus sine 1 by x is a positive quantity. So you are subtracting something from it, right? So it's going to be less than 2 for both 0 plus and 0 minus, right? And f of 0 minus, these both are less than 2, right? So if they're both less than 2, then I can say that 2 is going to be a point of local maxima for this function, right? So 0 is a point of local minima. This is incorrect, right? So the only correct option is option C. Cool. Right. Coming to the next one. All right. So this one, you have this matrix given, right? So let's rewrite this as, if you take alpha common, you'll get a matrix something like this, right? 0, 1, 0 and 1, 0, 0, right? Let's call this matrix some x, okay? So the property of this is that if you square x, you'll end up with identity, right? So from here, so x square is equal to I, a is nothing but alpha times x. So a square is going to be alpha square x square, right? Similarly, a cube is going to be, and x square is identity, so this just becomes alpha times identity. This will be alpha cube x. A4 is going to be alpha to the power 4. Again, identity, right? Okay, this is what we'll get. Now, if I look at this sum, okay, if I look at I plus a square, I'll get I plus a is alpha x plus this one is going to be alpha square identity, right? This will be alpha square identity plus alpha cube x plus alpha power 4 identity, right? So if I take the terms together, you'll get identity times 1 plus alpha square plus alpha power 4 plus alpha cube x, right? Now see, alpha plus alpha cube, or let's go with this, okay? This sum, the sum of all this is equal to 0, right? Which means this is nothing but minus of this. Or if you do it the other way, I can write this as, this will be minus of alpha plus alpha cube identity. So take this common, you'll end up with identity minus x, okay? Now this can be rewritten as, if I look at identity minus x, now this is easy to find. Identity minus x is going to be what? So 1, 0, 0, 0, 1, 0, 0, 0, 1 minus x is 0, 0, 1, 0, 1, 0, 1, 0, 0, right? So this just turns out to be 1 minus 0, 0, minus 1, right? 0, 0, this is going to be 0 again, right? Last one, 0, minus 1, so minus 1 here, 0 and 1, okay? So your final answer should be minus of this alpha plus alpha cube times this quantity. Now let's look at the options. So first one, you can see that it's plus of this, right? Okay. So identity minus x plus this, right? Okay. So alpha plus alpha cube. So this should be minus of alpha plus alpha cube, which can again be written as 1 plus alpha square plus alpha 4 times this matrix I minus x, okay? So if you look at it, 1, 0, minus 1, 0, 0, 0, minus 1, 0, 1, right? So it's going to be option A, okay? So that's the right answer for this one. Clear? Coming to the next one. Right. So in this question, you have what the eigenvalues and eigenvectors are. So observe that you have an idempotent matrix A. So from here, I can say that a square x minus ax should be equal to 0, right? Which means that a times ax minus ax is nothing but lambda x, right? This is also lambda x, so you get lambda ax minus lambda x is equal to 0. Now again, ax is lambda x, so this gives you lambda square x minus lambda x equal to 0. Now we know that x has to be non-zero, right? Which means lambda square minus lambda is equal to 0, so lambda is 0 or 1. But see, if lambda is equal to 0, in this expression, we'll get that determinant of A turns out to be 0, which is not allowed because A is non-singular, right? So we need lambda to be equal to 1. Now lambda is equal to 1, A is non-singular, and the only idempotent matrix we can consider is identity, right? So we can take A to be identity, lambda is equal to 1, right? Okay. Then what is the sum of the eigenvalues? So remember, sum of the eigenvalues is always nothing but the trace of the matrix, right? So what is the trace of this matrix going to be? It's an n cross n matrix. So the sum of the diagonal elements is going to be n, okay? As simple as that, okay? So this is question 29. Coming to question 30. Define a function fn which is integral 0 to 1 tan inverse of nth root of x dx, okay? Then which of the following is true? Right. So if you observe carefully, as n goes to infinity, this is nothing but, so if I write this, see, as x goes to infinity, this nth root is going to be x to the power 1 by n, right? So as n goes to infinity, this approaches 1, right? So this will just turn out to be tan inverse 1, okay? That is pi by 4, right? As n goes to infinity. Which means the sum of these two, fn and fn plus 2, both of them have to approach pi by 4, right? So the sum should be equal to pi by 2, right? So pi by 2, so hence it's not pi by 4. Sorry, it's not pi, okay? Next one is there exists a number n such that fn is greater than fn plus 1. If you look carefully, x lies in between 0 and 1. So what do we know? If I look at x to the power 1 by n, right, this should be, right, okay, which means tan inverse of this should also be this, right, because in between 0 and 1, tan inverse 1 is going to be increasing, right? So I get tan inverse of x to the power 1 by n less than tan inverse of x to the power 1 by n plus 1. Now integrated between 0 and 1, then you'll get that f of n is essentially going to be less than f of n plus 1, right? So it's a strictly increasing thing, okay? So you can't have an n such that fn is greater than n plus 1. And option C, fn is less than fn plus 1, and we know that this limit, it's an increasing function, it's bounded by pi by 4. We just saw that the limit is pi by 4, so option C is also correct, okay? Right? So the right options are option C and D, okay? All right. So the next question is, suppose P is a variable point on this ellipse and the foci are f1 and f2, the normal at P intersects the major axis at Q. If this ratio is 2:1, then find this ratio, okay? So what does our figure look like? So if I draw the ellipse, it will look something like this, right? Now suppose this is our variable point P, h comma k. Now what I do is I draw a normal from this, and suppose these are the two foci, right? f1 and f2. Now observe that by the property that this is a normal, we know that these two angles have to be equal, right? So they are both equal to some theta. Similarly, if this is alpha, this is going to be 180 minus alpha, right? Okay. Now if I use sine rule in these triangles, what can I say? I can say that Pf1 by sine of alpha is equal to, this point is Q, right? So Qf2 by sine theta, Qf1 by sine theta. Similarly, in this triangle, I'll get that Qf2 by sine theta should be equal to Pf2 by sine 180 minus alpha, which is just sine alpha, right? So this becomes Pf2 by sine 180 minus alpha, so just sine alpha, right? Which means if I divide this second equation by the first equation, or say the first equation by the second equation, I'll get Qf1 by Qf2 on the left hand side. And on the right hand side, what will I get? I'll get this Pf1 by Pf2 because sine alpha and sine theta are all going to cancel out, right? So this should be the same as Pf1 by Pf2, which ratio is already given to us, which is 2:1. Hence this ratio also has to be 2:1, right? So it's straightforward, simple, option C. Okay, cool. Coming to the next one. A and B are two fixed points on a fixed points on a straight line. Two circles are drawn on this line at A and B respectively and tangent to each other at the point M. When the circles vary, the locus of M forms what? Okay. So for this, observe that if these two are the centers, if I draw these lines, this is tangent, so this should be 180, and it's tangent at this point as well, okay? If I try to find this angle AMB, let's see what happens. Try to find this angle AMB. First of all, observe that this is 90. So this angle plus this angle, alpha, beta. Because it's a quadrilateral, two angles are 90, I can say that alpha plus beta should be pi by 2, right? Now, alpha plus beta is pi by 2. If you look at the rest of the angles, these two are equal. So this angle is nothing but 90 minus alpha by 2. Similarly, this angle is going to be 90 minus beta by 2, right? Sorry, this outer angle, okay? Now that plus this entire angle, the remaining angle should add up to 180, right? Sorry, 90 because it's tangent at this point, which means these two angles, AM, whatever this point x is, AMX is going to be 90 minus this, so just alpha by 2. Similarly, this is going to be beta by 2. So this angle AMB is nothing but alpha, sorry, this should be 180, right? 180 plus 180. So this is going to be alpha plus beta by 2, which just turns out to be 90, right? Which means no matter how this point M moves, this angle AMB is always a constant, right? And what locus does that define? It defines a circle, right, with diameter AB, but there is a catch, okay? Even though the options, there's only one circle. If you look carefully, if this point M collapses on this point A, then this does not really hold anymore, right? Because in that case, you can't really form this angle AMB, it's just going to be 0, right? Okay, I mean, one of them is going to be 0, the other one is going to be 180, right? So A and B points are not included, but otherwise it's going to form a circle with diameter AB, right? So option is option A, okay? Right. Go to the next one. Consider the diagram below where ABZP is a rectangle and ABCD and CXY are squares whose area add up to 1, okay? CXYZ actually. CXYZ forms a square whose area adds up to 1. Then find the maximum possible area of this other rectangle, right? So simply if I consider this to be y, then this side is also going to be y. Similarly, if I take this to be x, this is going to be x, right? And what is the condition given to us? That x square plus y square is equal to 1. And with this constraint, what do we want to maximize? See, this side of this rectangle is going to be y minus x, and the other side is just x, right? So we want to maximize x times y minus x, okay? Right? Cool. Now, if I take this x to be, say, cos alpha, and I take y to be sin alpha, I can always make the substitution, right? X square plus y square equal to 1, we are always allowed the substitution. Then this expression, x times y minus x, just turns out to be what? Cos alpha times sin alpha minus cos alpha, which will just give you sin alpha cos alpha minus cos square alpha, right? Now observe, if I multiply and divide by 2, what will I get? I'll get half of 2 sin alpha, which is 2 times sin alpha cos alpha, which is sin 2 alpha, right? Minus 2 cos square alpha. Okay? Now what do I know? 2 cos square alpha minus 1 is equal to cos 2 alpha, right? Okay? So from here, what will I be able to say? From here, if I replace 2 cos square alpha, say, so 2 minus 2 cos square alpha should just be minus 2 cos alpha, cos 2 alpha minus 1, right? Just switching sides. So I can plug this value over here, so this will turn out to be half of sin 2 alpha minus cos 2 alpha, minus minus becomes plus 1, right? Okay? Now this quantity is going to be bounded by how much? 1 by root 2. We know this, right? Any sin a sin x plus b sin y is bounded by minus a square root of a square plus b square and plus 1 by square root of a square plus b square, right? So this is going to be bounded by 1 by root 2 plus 1. So this overall quantity is bounded by half of, okay? So this just gives you root 2 plus 1 by 2. That is the maximum possible area, which is option D. Clear? So the entire trick in this question was just to go with these substitutions, because if you replace the value of x or y in this and then differentiate, it's going to become very messy, okay? So remember shortcuts like this, okay? It reduces the calculation a lot. Fine, so that's 33. Next one is, in a room with n greater than or equal to 2 people, each pair shakes hands between themselves with a probability 2 by n square and independently of other pairs, okay? If Pn is a probability that the number of handshakes is at most 1, then find limit n going to infinity Pn, okay? I say number of handshakes at most 1 means either the number of handshakes is equal to 0 or the number of handshakes is equal to 1, right? Now see, how many such pairs you have? You have n choose 2 pairs, right? Let's call it some k. So if none of them are shaking hands, what is the probability of one pair not shaking their hands? 1 minus 2 by n square. Now if all of them are not shaking hands, you'll raise this to power k, right? Because they're all independent of each other, right? So it's the probability that number of handshakes is equal to 0. Plus, if the number of handshakes is equal to 1, out of these k pairs, you choose one of them, that pair shakes hands, right? So times 2 by n square, and the remaining k minus 1 pairs, they do not shake hands, right? So this is your required probability, okay? Now to simplify this, if I take 1 minus 2 by n square whole to the power k minus 1 common, what will end up with? I'll get 1 minus 2 by n square plus 2k by n square, right? Now if I need to find this limit, observe that this obviously goes to 0. This quantity 2k by n square, k is what? N into n minus 1 by 2, right? So it's going to be some n square by n square, 2 by 2, so that will cancel out. So ultimately this quantity goes to 1 and you have another one, right? So this is basically twice the limit of this thing, right, as n goes to infinity, okay? Now observe that the limit of this is something of the form 1 to the power infinity. So this limit is nothing but e to the power minus 2 by n square times this k minus 1, so n into, so n square minus n minus 2 divided by n square, right? This is what I'll get, okay? Right? Now from here, what will I get? This will be some, wait 1 second, 2 by n square times k minus 1, right? Sorry, this will be by 2, okay? So this thing converges to what? This 2 and 2 cancels out, so this converges to e to the power minus 1. So the overall limit is going to be twice of e to the power minus 1, right? So that's option D, alright? So that is the answer. Coming to the next one, question 35. You have psi, which is a continuous function, such that its integral is equal to 1. Phi is another differentiable function, and find this limit, okay? So observe that what we can do here is simply put 1 minus phi equal to some delta t, right? In that case, you'll get minus dy is equal to delta dt, right? That's 1. And if you look at the limits, if I put the lower limit 1 minus delta over here, right? What will I get? I'll get 1 minus 1 plus delta. So the lower limit is t equal to 1, the upper limit is minus 1. So this turns into limit delta going to 0, 1 by delta, integral 1 to minus 1. Now y is going to be 1 minus delta t, right? Times psi of t minus delta dt, right? So this delta and this delta will cancel out. What you're left with is limit delta going to 0, integral. If I switch the limit, I can get rid of this minus sign, so this will become minus 1 to 1, 1 minus delta t psi t dt, right? Now observe, if I put delta equal to 0, this will just turn into phi of 1, right? So this is going to be phi of 1 times the integral minus 1 to 1 psi t dt, and this integral is given to you. This quantity is equal to 1, right? So this overall value just turns out to be phi of 1, okay? That's option A, alright? As simple as that, okay? Coming to question 36. Suppose ABCD is a parallelogram whose diagonals intersect at a point P. Let x and y be the feet of perpendiculars from P to AD and AB respectively. If AX is equal to 1, AY is equal to 2, BY is equal to 5, then compute DX. Okay. So what you can do here is just simply draw the figure, okay? So you have a parallelogram. Let's just, that looks something like this. Say ABCD, right? Join the diagonals. They intersect at a point P, right? Now from P you're dropping to perpendiculars, one here and one here, right? Let's say it looks something like this. So this on AD it's x, right? And here it's y. And what are the lengths given? So AY is given to be 2, AX is given to be 1, and BY is equal to 5. We have to find the value of dx, okay? So let's just assume that PY is equal to some k, okay? So I'm taking PY equal to some k. Then if I use Pythagoras theorem in this triangle, I'll get that PA is equal to root over k square plus 4. Now from here I can find out what Px is. So Px should be square root of this square minus 1. So k square plus 3, right? So we get these two directly. Now using this I can find PD again, right? Or let's forget, we don't really know dx, but we'll need this, okay? So we got the value of Px. Similarly in this triangle PYB, I can say that PB is equal to root over k square plus 25, right? Now we know the diagonals of a parallelogram, they'll always bisect each other, right? Which means PD should be equal to PB. So if PD square is equal to PB square. Now what is PD square? PD square is going to be PX square plus DX square. PX square is going to be K square plus 3 plus DX square should be equal to PB square, which is K square plus 25. Cancel this out. Send this to the other side, you get DX square is equal to 22, which means DX should be square root of 22, option A, okay? As simple as that. Alright, coming to the next one. In this triangle, CD is the median and BE is the altitude. Given that CD is equal to BE, what is the value of ACD? Okay. So this is the median, right? CD is the median, which means these two are equal, and this is a 90 degree, okay? Fine. Now after this, what you can do is, Let's say we use sine rule in the triangle. Let's go with, let's label them actually. Say this is some x. So this is also going to be some x, right? And apart from this, what else do we know? We know that CD is equal to BE. Fine. Now, if I look at the sine angle A, let's call this is angle A, and let's say we label this angle theta. All right. Cool. Now, observe that sine A, if I use say BE in this triangle, I can say that BE by sine A or sine A by BE should be equal to, this is 90, right? So it should just be equal to 2x, right? Okay. Or you can just simply go with the definition of sine A, same idea, okay? BE by 2x. So sine A should be equal to, sine A, this, so 1 divided by 2x, right? So sine A is basically BE by 2x. That's 1, okay? Now, again, if I use the same sine rule in the triangle DAC, okay? If I use it in DAC, what will I get? I'll get that x by sine theta. That should be equal to, I don't want AC, so I can take CD by sine A, right? Okay? And we want to find theta, right? So sine theta is going to be x sine A, so that is x into BE by 2x, x sine A divided by CD. Now BE is equal to CD, that's given, right? So this and this cancel out, x and x cancel out. So I get sine theta is equal to half, which means theta is nothing but pi by 6. So that's option D, okay? Just simple sine rule, okay? Fine. Coming to the next question. This is slightly tricky, it looks complicated, but it's actually just a little bit calculative, that's it, okay? First of all, observe that this limit can be rewritten as n going to infinity, n to the power minus 3 by 2. Inside this product, if I divide each of these individual terms by n to the power n plus k, then I'll get what? 1 plus k by n to the power n plus k. But because I've divided, I should also compromise by multiplying it, right? So this will become some n plus k, okay? This entire product to the power 1 by n square. Now if you just look at this, you're multiplying n to the power n plus k from k equal to 1 to n. That is just going to be n to the power summation of n plus k equal to 1 to n. So that's n to the power n square plus n into n plus 1 by 2, right? So that is n to the power 3n square plus n by 2, okay? Right? Now if I take this thing outside this root, what will I get? This will turn into n to the power minus 3 by 2 plus 3n square plus n by 2n square now because of this by n square that you'll get over there times inside the product. Now you have product of k equal to 1 to n, 1 plus k by n whole to the power 1 by n square, right? So this is the power n plus k, right? Now what does this quantity give you? See, 3n square by 2n square, right? So this will just turn into minus 3n square plus 3n square plus n divided by 2n square, right? So that just gives you n to the power n by 2n square, okay? So that's just basically n to the power some 1 by 2n, okay? Times from here what I'll do is I'll take one of these n's and put it inside, okay? So I'll get k equal to 1 to n. This will turn into 1 plus k by n whole to the power n plus k by n, right? So that will just become 1 plus k by n, right? Whole to the power 1 by n. So this is your required limit. Now what I'll do is I'll simply take log on both sides. I'll take log of this limit, right? So log of the limit will turn out to be what? If you look at it, from this first term you'll get n to the power n 1 by 2n, right? So that's 1 by 2n log n plus from here what will you get? You'll get 1 by n summation of these terms, right? What will I get from here? Summation of k equal to 1 to n, 1 plus k by n, log of 1 plus n, 1 plus k by n, right? Now this quantity we know obviously will go to 0, right? You can use L'Hopital, you can simply do this, ln x by x goes to 0, right? So this quantity will go to 0. This second limit just turns into the integral 0 to 1, 1 plus x, ln 1 plus x, right? dx, which is nothing but the limit 1 to 2 x ln x dx, right? Now this is a standard integral, you all know the value. This will just turn out to be what? So this should turn out to be, if I evaluate this using by parts, what will I get? So x square ln x by 2 minus, the second term should be what? X square by 4, right? So this in between 1 and 2. So that will give me what? 2 square, so that's 4 by, so 2 ln 2 minus 1 by 4, right? Sorry, minus 2 square 4 by 4, 1 minus log 1 will become, log 2 will give you 4 ln 2, wait 1 second. If I put 2, I'll get 2 square, so 4 ln 2 by 2 minus 4 by 4, so 1 minus, if I put 1 here, this will become 0, so minus 1 by 4, so 1 by 4, right? This just turns out to be how much? 2 ln 2, so that's ln 4 minus 3 by 4. So e to the power, this quantity should be what? This 4 comes out, so this will be 4 e to the power minus 3 by 4, right? That is your required limit L, okay? So that is the answer, option D, okay? Coming to the next one. Let n be a positive integer having 2025 divisors including 1 and n itself, which is denoted by 1 all the way till d 2025, then find the value of this product. This is a very simple standard result. Remember, for any number n, if d is a divisor, then so is n by d, right? Which means for all these, I can rewrite this as the same product. So n by di, so every divisor dk is going to correspond to some n by di as well, right? I equal to 1 till 2025. This is the same as this product. If I call this product p, then p should be equal to this, which is equal to n to the power 2025 times 1 by product of di. Now this product is nothing but p again, right? So if I cross multiply, what I'm getting is p square should be equal to n to the power 2025. So what is p? Square root of n to the power 2025, right? As simple as that. So that's option C. All right. Coming to question 40. Let us define a set S and T as follows. S is the first set, T is the second set. Find the number of elements in S intersection T, right? S intersection T means we want the product of these two quantities to be equal to half, which means I want sine pi theta by 1 plus theta. Theta and 1 by theta will cancel out times cos of pi theta by 1 plus theta. This quantity should be equal to half, right? Okay. All right. Now, if I multiply both sides by 2, I'll get that sine of twice of this, so 2 pi theta by 1 plus theta should be equal to 1, right? Now, what is the standard result for this? So, for this, 2n theta by 1 plus theta should be some 4k plus 1 times pi by 2, right? Okay, this is what I'll get. Now, from here, if I solve for n, what will I get? I'll get that n is going to be, this is 2 pi theta, sorry, not n, 2 pi theta, so pi and pi will cancel out. You'll get that 4k plus 1 should be equal to 4 theta by 1 plus theta, right? Okay. Fine. What else can we say from here? If you look at this inequality, we are getting that 4k plus 1 should be equal to 4 theta by 1 plus theta, right? Okay. Now see, theta by 1 plus theta definitely lies in between 0 and 1, right? Right, theta is always going to be less than 1 plus theta, right? So this quantity always lies in between. Right? So from there I can say that 4k plus 1 by 4 should also lie in between 0 and 1, which means 4k plus 1 should lie in between 4 and 0, which means k basically lies in between 3 by 4 and 0, right? Now what is k? K is a natural number for us, right? So what are the only natural numbers possible in this range? K equal to 0 is your only possibility, right? So if there's only one possible value of k, there's only going to be one possible value of theta, right? So what is this intersection going to contain? It's going to contain only one element, right? So that is option B, right? Okay. All right. Let's take the next one. So there are n teams in a pro kabaddi league. Each team plays against every other team exactly once. Suppose every game results in a win. That is, there are no draws in this tournament. Let W1 till W1 denote the number of wins and the losses of the teams T1 till Tn respectively. Then which of the following is true? So the first thing you need to observe is that every team plays how many matches? N-1 matches, right? Because there are n-1 other teams, right? So I know that no matter what happens, the number of wins plus the number of losses for the ith team is always a constant, right? It's always going to be n-1. All right. Similarly, if I look at the number of wins of all the teams, that should be equal to the number of losses of all the teams, right? Because every time someone wins a match, some other corresponding team has to lose that match, right? So if it gets added to one of these WIs here, it will also get added to some other LJ on the right hand side, right? So these two conditions you can directly say based on the idea of this tournament, right? Now observe that if I look at this quantity, say WI square minus summation of LI square, right? This is what? Summation of WI plus LI times WI minus LI, right? Now this is a constant, it's equal to n-1, so we can bring it outside, right? So this is just n-1 times summation of WI. I can split this term into two parts, right? Li, right? Now what do I know? This quantity is equal to 0. So this quantity also has to be equal to 0, which means summation of Wi square is also going to be equal to summation of Li squared, right? So which of the options is correct? Option B. As simple as that, okay? It looks complicated, but it's actually not, okay? You just need to understand what the idea is. All right. Coming to the next one. For any non-negative integer x and y, the function x comma y satisfies the condition that f of x comma 0 is equal to 0. X comma 0 is equal to x, and f of x comma y plus 1 is equal to f of x comma y, then which of the following is the largest? Okay. So if I just put y equal to 0 in this, what will I get? I'll get f of x comma 1. That should be equal to f of x comma 0, comma y, and y is just 0, right? Now f of x comma 0 is just x, so this turns into f of x comma 0, which is again equal to x, which means f of x comma 1 is just equal to x, right? Okay. If I look at f of x comma 2, now what will I do? I'll put y equal to 1 now, right? So if I put y equal to 1, I'll get f of x comma 1, comma 1, right? And that should be equal to f of, again, this quantity is equal to 1, sorry, x, we just proved it. And that is also equal to x, right? And so on and so forth, right? So if I keep any value of y, okay, so I can say from here that f of x comma y is going to be equal to x for every y in natural numbers, right? Now once I get this, observe that what is going to determine the value of these functions? It's going to be the x value, right? So the larger the value of x, the larger this overall function is. Among these, 14 is the largest, so f14, 11 should be the largest value, right? That is 42. All right, let's look at the next question. So 43. Let f and x be x repeated n times, then which of the following is the value of this? Okay, observe that this is a very standard form. Whenever you have a digit that gets repeated n times, what do you write this number as? This is nothing but x times 111 n times, right? It's going to be x times, this is what the sum of the GP 1 plus 10 all the way till 10 power n minus 1. So that should just turn out to be 10 power n minus 1 by 9, right? So if I look at these two individual things, so 3 is, you put x equal to 3, so that becomes 1 by 3, 10 to the power n minus 1 whole squared plus 2 by 9 times 10 to the power n minus 1. So this will turn out to be what? 1 by 9, so 10 power 2n plus 1 minus 2, 10 to the power n divided by 9, right? Plus 2 by 9 times 10 to the power n minus 2 by 9, right? So from here, this term and this term cancels out. These two terms will give you what? Minus 1. So this becomes 10 to the power 2 and minus 1 by 9. And what is this number now? This basically, with the same argument, x is equal to 1 and it has 2 n digits, right? So it's basically 2 and 1s, one after the other, right? So that is option B, okay? As simple as that. Coming to the next one. 44. Let ABCD be a parallelogram with AB equal to 1, ABC equal to 120. The angle bisectors trisect the quadrilateral into 3 regions of equal area, right? So this is what our figure looks like, right? Suppose this is AB, CD. So we draw the angle bisectors. It should look something like this, right? Okay. Let's say that these three regions have equal areas, alright. Further, AB is equal to 1, fine. ABC is 120, right? So if ABC is 120, these two angles are going to be 60 each. Similarly, these two angles are going to be 60 each, right? Now again, because it's a parallelogram, if this angle is 120, this angle by default has to be 60, right? Which means that these two triangles are individually what? Equilateral triangles, okay? Now let's assume that the side length of AD is some x, okay? Suppose it's some x, and x is the value that we need to find, right? We need to find the value of BC. So the areas of this, so area of this should be equal to what? Area of this equal to this equal to this should be equal to 1/3 the area of the overall parallelogram, right? So area of this triangle is √3/4 x squared, and that should be equal to 1/3 the area of the parallelogram, which is just base into height. Now base is equal to 1, height is √3/2x, right? Here it's going to be √3/2x, so this should be equal to √3/2x, okay? So x and x cancels out, √3 cancels out, you have a 2 here, so you get that the value of x is nothing but 2/3, okay? So this turns out to be 2/3, alright? That's question 44. Go to question 45. How many ordered triplets of integers a greater than or equal to 2, b greater than or equal to 1, and c greater than or equal to 2, greater than or equal to 0 satisfy both this and this, okay? So observe that what does this imply? This implies that b is equal to a to the power c to the power 2025, right? Now see, a is a number that's greater than or equal to 2, right? If somehow c is also greater than or equal to 2, then this number itself becomes greater than 2 to the power 2025. But we have this constant that the sum of these three is equal to 2025, right? So if c is somehow greater than 2, this condition won't be satisfied. So which means we can't take c greater than 2, we can take c equal to 0 or 1. These are the only two values, right? Now see, if we take c equal to 0, what happens? 0 to the power anything will become 0, so this becomes a to the power 0, which is 1, right? So b becomes 1. So a is going to be, so 2024, right? So that's one triplet, okay? 0, 1, 2024 is one triplet. If c is equal to 1, we get that b is equal to a, so a is equal to b, and c is equal to 1, right? Which means a equal to b equal to 1, 0, 1, 2, right? And c equal to 1. So these are your two possible triplets, okay? So how many ordered triplets are there? 2. That's it, okay? That's 45. 46. How many of the first 10 numbers in the sequence 1 to 1, 1, 1, 2, 1, 1, and so on and so forth are prime numbers, okay? So for this, what we'll do is we'll start off by trying to find the general term of this expansion, okay? The closed form for the general term of this expansion. So if you just factorize this, you'll see that this just turns out to be 11 times 11. This turns out to be 101 times 111. This will turn out to be 1001 times 1111, and so on and so forth, right? So basically, it's a string of ones multiplied by a power of 1 plus 1, right? Now what can I write this as? So if we look at the nth term of this, it's going to be 10 to the power n plus 1, right? Times this number we already know, it turns out to be 10 to the power n minus 1 by 9. Okay? So this is what we are getting. Clear? Now from here, we need to see which of them are divisible, right? Which of them are not primes, okay? Now observe that this number, okay, this is divisible by 9, right? So this number is some 9 into k, right? Or you don't even need that. Just observe that all of them are getting multiplied. If these are product of two numbers, they're obviously not going to be primes, right? So the answer is just simply 0. We don't even have to go further, okay? It's just the product of two quantities. This is an integer, this is an integer, right? Product of two integers, which means it can't be a prime, okay? So number of primes is equal to 0. Next one, suppose we have a function fx which satisfies the following condition, that f of x plus y is equal to fx plus fy divided by 1 plus xy, and f prime 0 is equal to 1. Then, and if x is also in between minus 1 and 1, then which of the following intervals is 1 where fx is increasing? Okay. So for this, if I go by the definition of f prime, what is f prime x? H going to 0. F of x plus h minus fx divided by h, right? Now from here, this can be written as what? X plus h is nothing but this quantity. So this is f of, so I'll ignore the limit for the time being. So it's going to be f of x plus f of h divided by 1 plus fx fh minus f of x divided by h, right? Okay. Which can further be simplified as, if I multiply, I'll get what? I'll get fx plus f of h minus fx minus fx fh divided by h, right? So this one just cancels out. If I take fh common, I'll get fh by h times 1 minus fx, right? Sorry, this will become f square, right? Once you multiply. So 1 minus f square x. Okay, limit h going to 0. Now see, this quantity is independent of h, right? And this limit is nothing but f prime 0. So this just turns out to be f prime 0 times 1 minus f square x, right? If you look at f prime 0, it's equal to 1, so forget about this. So this is what the value of f prime x is for any value of x, right? Now see, fx lies in between 0 and 1, right? Which means this quantity is positive, right? Since fx lies in between minus 1 and 1, this quantity is going to be positive, which means it's going to be increasing for all values of x, hence it's increasing on all of reals, okay? That's it. All right, so let's look at the next question. So this sum can be expressed as some natural number n, then find the last three digits of 2021 factorial times n. So for this, observe one simple thing, that if I look at 1 by n minus 1 factorial plus 1 by n minus 2 factorial, this simplifies to n minus 1 factorial, n minus 1 plus 1, so that's n by n minus 1 factorial, right, which can be written as n square by n factorial multiplying dividing it by n. So if you look at every term of a general term of this is going to look like n square minus 2 by n factorial, right? So this term can be split as n square by n factorial minus 2 by n factorial. Now this I can further break down using this, okay? So any general term of this, okay, it's going to look like 1 by n minus 1 factorial plus 1 by n minus 2 factorial minus 2 by n factorial, right? Now if you look at the first couple of terms, you'll get an idea what happens to the series, okay? So keep s as, write this as s, you'll get 1 square minus 2 factorial by 1 factorial plus, from the second term onwards I can split it by like this, right? So this will become n equal to 2, so 1 by 1 factorial minus 1 by 0 factorial minus 2 by 2 factorial. The next term is going to be, if I put n equal to 3 now, so 2 factorial, 3 is going to give you 1 by 1 factorial minus 2 by 3 factorial plus the next term, if I put n equal to 4, I get 4 minus 1, 3 factorial, 4 minus 2, 2 factorial, minus 2 by 4 factorial, right? And so on and so forth till the last term. Now observe that this 2 by 2 factorial term, this will cancel out 1 2 factorial from here, 1 2 factorial from here, right? Same for 3. 3 will cancel out 1 from here and 1 from the next one. You understand? Right? So for any 2 by n factorial, it cancels out the next two terms, right? So ultimately in the end, once you use this telescopic idea, what are the terms you're going to be left out with? One of them is this term, right? So let's look at the terms that are left out. 1 square minus 2 factorial, which is 1 minus 2, so that's minus 1, right? So s is going to be minus 1 plus, what are the other terms that are going to remain? So it will be the last couple of terms, right? Okay, so if I continue this all the way, if I look at the last couple of terms, say I go from 2018. So if I put n equal to 2019, it goes all the way till 21, right? So let's look at the last three. 2019 minus 1, 19, 20, 21. So 2019 minus 1, right, is going to give you 2018 factorial minus, sorry, plus 1 by 2017 factorial minus 2 by 2019 factorial. Then same for 20. So 20 minus 1 is 19, 18, 2020. Plus the last term is going to be 2021. So 2020 factorial minus 2019 factorial plus 2 by 2021 factorial, right? These are the last couple of terms. So now from here, if you cancel these terms out, what will happen? See, 2019 gets cancelled out. So 2017 is going to cancel out with the previous terms, right? 2017 term is going to be the previous one, right? These are also going to cancel out. The terms that are left out are what? Similarly, 2018 is also going to cancel out, right? The previous term before this will give you the 2018 one, right? This is T 2019. So T 2018 does cancel out, right? T 2017 is also going to cancel out. So the only terms that are going to be left are the 2020 and this one, right? So what does that give you? You'll get a minus 2 plus 1, right? So minus 1 by 2020 factorial, right? Plus 2 by 2021 factorial, right? These are the terms that are going to be left out. So if you look at s times 2021 factorial, that is going to be minus 2021 factorial minus 2021 plus 2, right? This is what you're going to end up with, right? Now observe that. If you simply look at this, 2021 factorial ends with a lot of zeros, right? 2021 ends with a lot of zeros, okay? So, sorry, this should have been a minus, right? So you're basically in some sense subtracting 2021 from 1000 and then a -2, right? Whatever this ends with, that is going to be the last 3 digits of this number, right? Okay. So if you subtract this, what will you end up with? So you can just subtract. So it will be what? Let's go with 10,000, just for the sake of calculation. 2021, you end up with 9. This will become 9, so 7. This will become 9, so 9. This will become 9, right? So 7. And then you're subtracting 2 from it, right? So you get 977, okay? So last 3 digits of this number are going to be 977, okay? That is option B. Okay? Coming to question 49. 49 से पहले एक बार कट लगाना, ऑप्शन एडिट करना है, अब एक कट लगा दिया, ठीक है. Alright, coming to the next one. Suppose limit t going to x 0 to t 1 minus f square minus 0 to x 1 minus f square ds divided by ft minus fx is equal to fx, okay? So observe that I can literally write this as some function gx, okay? So if I define a function gx to be integral 0 to x 1 minus f, I don't know, some variable, say fu square du, right? Then this numerator is nothing but g of t minus g of x divided by ft minus fx, the limit of this, right? T going to x. By L'Hopital, this is going to be nothing but g prime x by f prime x, right? And g prime x from here is going to be what? Root over 1 minus fx squared. So this would imply that g prime t, so 1 minus fx squared by f prime x is equal to fx. So if I integrate this, I cross multiply and integrate this, what will I end up with? Fx is going to be, how much should I get? It will become f prime x fx divided by 1 minus fx squared, right? So that should just give me that root over 1 minus y square. So I get a root over 1 minus fx square, right? Let's just do it. So cross multiplying, I'll get f prime x times fx. Let's go with dx, okay? Is equal to dx, okay? So if I put fx equal to y, you'll get dy by root over 1 minus y square. Y is equal to dx. Integrate this. So this gives you what? This integral should turn out to be minus 2y. Minus 2 over here, right? You put this. So this is going to be 1 minus y square equal to t, right? This is going to be root t, right? So this is going to be root over 1 minus y square is equal to some x plus some constant, right? Okay, so x plus some constant. So now if I put the value of x as what? Half, you see you get only one unique value of c, right? Either way. So when I square this, I can find y square now, right? So y square is going to be 1 minus x plus c whole square and the square root of that, right? Okay? Right? So now if you solve this, okay, let's solve for the values. So y square is equal to this. Right. So now let's solve for the value of c. So 1 minus y square. If I put x equal to half, I'll get 1 minus 3. So that's 3 by 4. So 3 by 4 is 1 by 4, so half. So c is basically equal to 0 for us, okay? So this is basically 1 minus x square. C is going to be 0 for us, so this is 1 minus x square. So f of 1 by 4 is going to be what? Let's see, this is going to be plus or minus, right? Because you're taking square roots after squaring it, right? So this is going to be y equal to plus or minus 1 minus x square, okay? So that should give me what? That is going to be 1 minus 1 by 16. So that's 15 by 16, right? And the square root of that, right? That should be what? Root 15 by 4, okay? But observe that plus or minus root 15 by 4, but यहाँ पे कट लगा देना, ठीक है? टेम्परेरीली ये मिट गया था बीच में. उसके सॉल्व के बाद यहाँ पे कट लगा देना. But observe that plus or minus f is a 0 1 to 0 1 function, right? So out of the two values that you're getting, root 15 by 4, only one of them is acceptable, which is the positive one, right? So what is your answer? It's just option A, okay? Right? That's the final answer. Coming to the next one. Okay, so you have an artillery target which might be either at point A or B, right? So at A, the probability of the target being is 8 by 9. The probability of it being at B is 1 by 9, right? Now you're firing shells from a certain point, right? Let's say out of the 21 you fire x towards A and you fire 21 minus x towards B. Then the probability that the target is destroyed is going to be what? So first of all, it needs to be at A for it to destroy. So 8 by 9 times the probability one of them hits it. So that is going to be 1 minus the probability that none of them hit it, right? So 1 minus half to the power x. Similarly for B, it's going to be 1 by 9. 1 minus, now you are targeting 21 minus x, right? So this is your required probability. And this is a function of x and you want to maximize it, right? So if I look at f prime x, it will turn out to be 8 by 9 half to the power x ln half plus 1 by 9 half to the power, sorry, there will be a minus as well. So minus of this 21 minus x times ln half times a minus 1 because of this 21 minus x, right? You want this quantity to be 0. So minus minus becomes plus, this ln half will cancel out from both sides. So ultimately what you want is, you want 8 by 9 half to the power x to be equal to 1 by 9 half to the power 21 minus x. This cancels out. You want 2 cube to be equal to, this will become 2 power 21 minus 2x. Sorry, this is 2 cube should be equal to half to the power 21 minus 2x, which is 2 power 2x minus 21, which means 2x minus 21. So 2x is going to be 24. So the value of x is 12, right? So to maximize this, you want to fire 12 shells towards A, right? So answer is option B. Okay, so that takes care of 50 important questions. Let's look at one bonus one. Okay, find this integral 0 to n to the power 1 by k box of x to the power k plus n. Okay, so this integral, observe, this can be broken down as summation I equal to 0 to n minus 1 integral I to the power 1 by k till I plus 1 whole to the power 1 by k box of x to the power k plus n dx. Now if x lies in between these 2 points, then x to the power k lies in between I and I plus 1. So box of this is going to be I, and is a natural number, so we can always take it outside box, right? This just turns out to be I equal to 0 to n minus 1 integral I to the power 1 by k I plus 1 whole to the power 1 by k I plus n dx. Now this is a constant independent of x, right? So this is just going to be the length of the interval, right? 0 to n minus 1 I plus 1 whole to the power 1 by k minus I to the power 1 by k times I plus n. So if I multiply this out, I'll get what? So I'll get 2 summations, right? One of them is going to be n plus I plus 1 whole to the power 1 by k, I equal to 0 to n minus 1 minus n plus I times I to the power 1 by k, I equal to 0 to n minus 1 again. Now observe that if I shift the limit slightly, okay, if I shift the limit slightly, if I replace I with, say, I plus 1, okay, in the second one, or let's go with in the first one. If I replace I with I plus 1, what will I get? So this will turn into summation I equal to, so this starts from n plus 0, right, all the way to 1 to the power 1 by k. This starts from 0, so that first term gets cancelled out anyways. So, yeah. So if I replace the first one with, let's go with I minus 1, okay. If I go with I minus 1, then this will turn into n plus I minus 1 times I to the power 1 by k. And see, this was starting from 1, right? So now this I should start from where? I should start from just, initially, it was starting from 1, right? So it should just start from 1. So I equal to 1 to n minus 1 minus, ignore the first term because I is going to be 0 anyways. So I from 1 to n minus 1, n plus I times I to the power 1 by k. Now if you look at the difference of these two terms, this was initially going till n, right? So it should start from 1 and go all the way till n, right? See now this nth term is missing in the second one, right? So let's take care of it separately. You'll get what? Now observe that if you take care of these I equal to 1 to n minus 1 terms together, it's n plus I minus 1 minus n minus I, right? So you'll be left with minus 1 to the power I times I to the power 1 by k, right? So one term that you get is minus of I equal to 0 till n minus 1 I to the power 1 by k. That's one term that you'll get. Now if you look at the other terms, the other term is basically n, right? So if I look at the nth term, it's going to be n plus n minus 1, so that's 2n minus 1. So that is going to be 2n minus 1 times n to the power 1 by k. And then you have the second term, right? So now take this minus 1 and combine it here, right? So you'll get 2n times n to the power 1 by k minus, now the summation is going to run from 0 all the way till n, right? Or 1 all the way till n. We don't care about 0. So this will be this. And this can be again written as twice of n to the power k plus 1 by k minus summation of I equal to 1 to n I to the power 1 by k, right? So that is your final answer, which is option B for us, okay? So that takes care of the 50 most important questions for you for NEST this year. Hopefully, this was a brief summary of all the topics that you need, okay? So apart from this, if you feel like there's any particular topic or subtopic that you're slightly struggling a little, so make sure you go back and revise that. And all the best for NEST.